Hi. Hi, Adam.
Hey, Georgie, how are you?
Good, thank you. How are you this morning?
I am good. Thank you. How are you? Are you back home or are you back in Australia?
No.
Oh, no.
No, we're still in level 4 lockdown in Auckland.
Georgie. Oh, Georgie.
So they're revising that on Monday at Cabinet.
So does that mean you can't leave?
No, there's no planes flying.
Oh, okay. Because I'm thinking, sure, they can let you out. They're not worried if you go, right? It's coming back in. That's Georgie.
So, yes, it's an adventure.
How long
I
has
don't
it
think I'll
been?
be booking a holiday anytime soon.
How long has it been now?
I have been here a month longer than I anticipated. So it's been 9 weeks since I've been in the office.
Wow.
Yeah.
You've had 2 years worth of New Zealand visiting.
You're
in credit now. So family, I'll see you in 3 years.
How about you? How's Brisbane?
Oh, fine. We actually just moved into our new office yesterday, so it's a bit of a bomb site behind me.
It looks like a different background.
Yeah, it's been a little bit insane. But we're in here now, and Robin will be here in a couple of hours. So the office of 2 for the first time in a long time. So
yeah, nice.
But yeah, no, all good. Very busy. It's this used to be in an analog pre-COVID world. This was a really busy time of year. We'd be gearing up for Smart Cities Week, and then it's Barcelona, and then it's just it seems to be the same, but just all virtually at the moment. So yeah, it's all good. It's fine.
That's good.
So who else is with us? This is meant to kick off in 15 minutes, isn't it?
It is. Yes.
Yes. Our Sense and Serve host. Is there someone there? Maybe not yet.
I haven't heard from them yet.
And the recording is underway. Okay. It is. What's that background, Georgie?
This is Hallett Cove Beach. This is the City of Marion coastline. So yeah, it's a beautiful spot. It's not really habitable. So we have a walkway that goes through the dunes and hills in Hallett Cove, but it's not really a beach people go down to very often.
Yeah, very rocky.
Yes.
Like very different environment.
Yeah, so it runs along. No, we can't hear you. Audio dead, Drew.
Oh.
It goes along beside Glenelg and Brighton, so that's a real beach environment.
Oh, right. Yeah.
So it's the same coastline as that. It's just further down south.
Yeah. It's beautiful.
Yeah, I love the ocean.
Is the rock face? Is that how orange it is, or is that like a sunset, really, or a sunrise?
That's a sunset.
Yeah.
But it is quite red rock. Yeah.
Yeah. Okay. Test my screen share. Yes, certainly. Let me just do that now. Share screen. Oh, the host has disabled participant screen sharing. Need to disable the lock on participant screen sharing. Please retry. Excellent. There we go. Can you see that?
Yes.
Georgie, yes. Can Sense and Serve see that? I'll assume yes.
Yeah, you got a thumbs up.
Okay. Excellent. Thank you.
sense, and serve. Very nice to see everyone here and online. This is an event where we're bringing together local government innovators from around the country to learn about and share ways in which we can use smart technologies to improve the way we serve our communities. We're coming to you live from the Perugian Digital Hub. And the Perugian Digital Hub, for those of you that don't know, is a Noosa Council initiative to accelerate the technology industry and digital industry here in this region. My name is Chris Bowden, and I'm Noosa Council's Digital Hub Director. Very nice to be with you today. And Perugian Beach is Cubby country. I'd certainly like to pay my respects to elders past and present for their custodianship of this beautiful land. And lovely to have some of our friends here today. This event would not have been possible without the support of Noosa Council, and I'd like to welcome our Mayor, Claire Stewart, along with councillors and staff as well. The event's been organized by, co-organized by our partners Meshed, and I'd like to thank Catherine, Paul, and the team for all of and you'll be meeting them a little bit later today. Like many LGAs attending online and in person here today, Noosa Council is powered by the Technology One Cloud, and their support of the Digital Hub has really been what's enabled us to put this and many other events like this, host them and put them on for the benefit of the broader LGA community. So thank you to Technology One. That's about enough about us. At the event today, we've got around 250 attendees, around 50 in person here at the Hub and around 200 online. There are about 150 LGA innovators joining us today, and they represent over 80 councils from around the country. I think every state is represented by the NT and Tasmania, so we've got work to do for next year. What I've learned from, in particular, the last few months of meeting and chatting with smart cities and smart technologies folks at these councils around the country is, in my observation, they're some of the most innovative people working in local government. So I'd venture to say that with 150 odd of these folks online, we've probably got a concentration of some of the most change makers in local government. So fantastic to have you all joining us today. Now to the why of why we're here and what we're going to be talking about. I think we can all agree that local government in 2021, September 2021, is probably as complex as it has ever been. Not that I've been doing it for 100 years, but in the 3 years I've been involved, I've seen obviously a massive level up in terms of the complexity. The social, economic, and environmental challenges that we're seeing are more acute than ever. And this is, of course, driven by rapid changes due to COVID, the obvious one, but climate and technology in particular. If I think about what it's like in terms of the challenges that we face here in Noosa, our challenges all revolve around those kinds of things. We're facing some massive challenges around our climate adaptation. We're facing some major challenges around how we adapt from an economic perspective in terms of the COVID impact. And we're playing catch up really with the speed at which our communities are using technology and how they're using technology. For example, a major challenge for us in our LGA is how we deal with the challenge of short-term accommodation, where new technologies like Airbnb and others have enabled people to generate new income streams from letting their property. That kind of use of technology is driving massive changes in how our shire operates. And indeed, more recently, the acceleration of remote work is changing massively the socioeconomic nature of our town, with huge people movements and mobility, pressures on accommodation and things like that. So these are major challenges that we as LGA practitioners, if you like, are facing. Our communities have become a lot more tech savvy. They're obviously requiring a lot more support in the current context, and they're demanding a lot more transparency from us, largely through the use of social media. This is requiring us to provide a lot more transparency about how decisions are made. But this event isn't focusing on the challenges per se. This event is focusing on the solutions. And what we've brought today, what we've brought together is a group of some of the key people, the leading thinkers and innovators in the space, who are figuring out how they can use technology to address some of those challenges and better serve their communities. So you're going to hear lightning presentations from around 15 folks who are working at the cutting edge, both in their councils as well as on the solution side. You're going to hear from some fantastic technology companies who are working on very, very innovative sensing and data solutions that are going to make our jobs easier in the years ahead. And then finally, we're going to give you the chance to have a Q&A session with whoever you would like to pick from the speakers that you hear from today. Without further ado, I'd like to welcome our first presenter, Adam Beck. Adam is the Exec Director of the Smart Cities Council, Australia and New Zealand. And he has an amazing helicopter view of what is happening in the world of smart cities and how technology is being used at local government, state and federal level as well. So I'd like to welcome Adam and hand over to him.
Chris, thank you so much for the invitation, and also to Catherine and Paul and the team at Meshed for inviting me today. I'd like to start by acknowledging the First Nations people as the custodians of the land at which I'm coming to you today virtually in this meeting, which is in Brisbane, Queensland. And I want to recognise the land north and south of the Brisbane River as land of the Jagera and Turrbal nations and pay respect to their elders past, present and future. I've got a short presentation here, really just a bit of a taster, sharing some work that we've been evolving, which is ongoing for the next couple of years around the future of place. You have got an excellent lineup of both government and private sector leaders going to deep dive today with you around IoT and how it is a core enabler of helping us build better, resilient, safer communities and cities. And really what I wanted to share with you is sort of how we're thinking about potentially what's next, or what we do need to think about what's next when it comes to enabling our cities through tech and data. For those of you that don't know the Smart Cities Council, we've been around almost a decade globally, 5 years in Australia. We're a member-based organisation. You can head to our member-based showcase website to see some of the organisations that are part of our community, and certainly want to acknowledge some of those friends that are on the line today. I can't stress enough, and I start all our presentations by ensuring that we're very well grounded with a North Star when it comes to the work that we do in technology and data and city shaping for better. The UN's Sustainable Development Goals are indeed the North Star for the Smart Cities Council, and I'll be bold and say that it's the superior framework for IoT and smart cities. It draws some sort of curious questions at times, but when you look at the global goals, we're a signatory to it in Australia and also New Zealand. They're global, they unite us, they're time-bound. They're very diverse and they can be localized. We are still yet to find a better framework for guiding the work that we do, and indeed the work that we think that we all need to be advancing. I want to talk about place as sort of the next major frontier and platform for advancing smart cities and IoT. The outcomes are the same. We've been creating and shaping great places for people for a long time. And indeed, the reason I'm focusing on place in this presentation is that place is a big part of local government, what it stands for, what it is. Public places are our places. It's democracy, it's health, it's well-being, it's community connection. And indeed, the other reason I'm touching on this as a theme today is because COVID has certainly turned things around when it comes to sort of the way we look and think about how place is being used and how we interact with it. We always know that our places need to be for all. They need to be equitable, and that doesn't change, and it hasn't changed. They need to be places that we can engage with at any time of day, in any place. These are certainly aspirations that we all have in local government and indeed state government and private sector. But that idea of place is changing. We believe at the Smart Cities Council, this relationship, this very interesting relationship, this evolving, fast-paced evolution of a relationship between people, place, technology, and data is one that's been happening for some time, but I'd certainly be confident in saying the last 12 to 18 months has certainly seen the relationship go to places, I think, that we haven't been before. The Future of Place project, which I'm sort of referring to now, is this 2-year journey that the Smart Cities Council is going through of trying to understand what that relationship looks like, how it's evolving. We've been doing a lot of discovery, a lot of scoping, a lot of engagement. What we're finding, this is just a mere snapshot of about 40 to 50 issues that relate to place and local government, that when we look behind each of these images and each of these tiles, there is a tightening relationship between people, place, tech, and data. And the reason I sort of bring this up in this forum is because behind each of those tiles, in the context of what a smart city is, and we know that a smart city is one that uses tech and data for good. That might be sort of what a smart city is, but its core function, of course, is where it really has a strong intersection with the Internet of Things. IoT is an underpinning element of smart cities because there's 3 core parts to a smart city, which is to collect, communicate, and crunch data. And it provides very strong context for IoT. But how we're collecting and how we're communicating and how we're crunching data is changing every day. And the innovators out there that are using those core enablers, like networks, like sensors, like analytics, those innovators are stretching our minds on an ongoing basis. And during COVID, we certainly saw our public places and the relationship and how our communities engaged with place, whether it be through their enhanced digital lifestyles, whether it was urban food delivery, e-commerce, double-digit growth in Australia. Our digital lifestyles and the digital backbone that we're using and the role that IoT plays, each and every one of those digital decisions has a physical impact. And that's fascinating to us. While we sit on our lounge and order a Japanese ramen that gets delivered to our door, there is a physical impact there. And as custodians of the public realm, local government has a job to ensure that we're nurturing the best places for people. And the question we're asking is how and what is the role of tech and data in supporting that goal? Now, the Internet of Things, of course, is certainly an agenda that involves networks, it involves sensors and instrumentation and control, many different devices, and then, of course, hopefully doing something with that data. But in the public realm, we are sensing more. We are gathering more data. We are deploying more devices. And this can't be underestimated in terms of the concern that some have, but also we can't underestimate the huge opportunity that we have as well in doing so. As we look to scale and replicate the Internet of Things through our places to help them be better for people, there are some really important topics and issues and themes and rules and regulations, in fact, that we need to be conscious of. And our work on data leadership, those 5 vitals are absolutely fundamental. Having a purpose for collecting data in the first place, ensuring that we wrap around it, embed it, privacy and security, ensuring that we've got good frameworks or at least strong considerations and can have a conversation or respond to issues around ethics and around governance. Those are the starting points for data leadership. And indeed, with IoT in the public realm, we're seeing certainly some excellent advancements in some of those 5 issues, but no one's doing all 5 to the extent that we need to. So we need to ensure that all of our advancements and innovations are done with that strong lens of data leadership. On exploring the relationship, people, place, tech and data, it's a weird and wonderful journey that we've been going through. This is just, these are just some of the topics that we've been unpacking throughout 2021. We've still got another 1.5 years to go on the Future of Place project. It is not dramatic for me to say that the pace of innovation is eye-watering. And when the pace is very rapid and the excitement is high, the risk is that cities have this stuff done to them as opposed to nurturing and stewarding the best outcomes for people through place. We don't have answers yet. We will hopefully have guidance that comes up in our handbook in about 1.5 years' time, but we need to go on this journey to see what cities are doing now, how we're winning, how we're failing, and indeed hear from the rich ecosystem of public, private sector and academia on what's coming, what people are thinking, and what the impact is between digital data and people and place. We saw over the last 12 to 18 months, cities go on very important, interesting, rapid journeys, whether it was setting up an analytics capability within an organisation like Brisbane City Council that put in place their City Analytics Office, which of course was sort of compressed and became more urgent. But this is really great to see cities understanding not just what they collect and sense more data, but then making sense of it and reporting and then informing the little money they do have of ratepayers to try and make a difference in a time that is very challenging. Well, you know, we see record investments around the country in some places. The City of Darwin, one of our members, spending record amounts of money to digitally connect their CBD, very clearly grounded in the ideas of economic development and leveraging tourism. But of course, you know, certainly not without challenges along the way in terms of data and managing that. But from challenges come fantastic outcomes. And indeed, City of Darwin has done some leading work around AI and also privacy, which hopefully we'll be seeing shortly in the public realm for them to share with other councils. So excellent work going on. And I put some of these sort of leaders up on the screen, more so to sort of prompt who you need to reach out to and who you need to connect. You don't need to do this on your own. 5 years ago, we were struggling. We set up the Smart Cities Council and there were 40 cities that were doing it. And when I say doing it, I mean a plan, a strategy, some proof of concepts, a bit of budget. But we now have more than 100, more than 150. Whatever you're thinking you might want to do, I'll sort of bet on it that it's been done about 70 times prior across Australia and New Zealand. So building that peer network is fundamental. Moreton Bay Regional Council is another one, and I love kind of the way in which they go to some unsexy places at times with IoT. I spent a lot of time digging into council budgets, and I'm flabbergasted, if I can use that word, sometimes at where money is spent. It's spent wisely, but in some of the areas in asset maintenance where surely there's an opportunity to spend 30% less, 40% less. We've got local authorities out there spending $9 to $19 million a year just on filling potholes. let's use tech and data and IoT to drive that down. Let's reduce that. Let's set goals, 20% less, 30% less. So we have some great innovators and leaders around the nation. You'll hear from Georgie in a moment. We did a virtual 2-hour tour of the Oakland Smart Precinct just the other week. It was fantastic in the role of IoT in really bringing that space to life. And what I really love about it is the data that Georgie and the team are now able to sort of, look through, go through that internal transformation process of using that data to make better decisions and expenditure and amend policy. That's when we know the shift is happening and we're in the right direction. Last week, we did a virtual tour down on a greenfield site, a large community in Queanbeyan and Palorang. Their efforts underpinned by the Internet of Things, gathering data in real time, a great community app. I love how that we're spending time to test these opportunities in all different environments, regions. IoT is scale neutral, it's geography neutral. Data doesn't discriminate. It is certainly for everyone. I'll leave you with a final slide. This is a bit of sort of what's next. This is what we're trying to work out. We're building a future of place framework at the moment. This is a quick screenshot this morning of a lot of the engagement that's going on. We're doing a lot of discovery, unpacking these issues. It's evolving every day. We think place is the next frontier in terms of the platform for accelerating tech and data enabled communities for better. We look forward to hopefully hearing more from those that are on the line and sharing their great stories. We'll certainly do the same. We share all of our information back. Our goal, of course, is to grow the pie and accelerate better outcomes for people, planet, and also prosperity. Chris, with that, I'll stop. Thank you so much for your time.
Big hand for Adam. Thank you very much, Adam. We always have a danger in technology gatherings of making assumptions about everyone's level of knowledge. And I thought before we dive into some of the sort of significant discussions that will come later, it might be worth just spending a few minutes sort of demystifying some of the terms that you're going to be hearing today so that you have a better sense of how these things kind of map together. So to do that, I'm going to call on our smart technologies experts to just come and spend a few minutes with me up on stage here and help us just understand these terms, and then we'll keep going with the discussions. Please welcome Paul and Catherine from Meshed. I've just picked 4 terms that we're going to quickly talk about, particularly for those people who don't necessarily have a very good handle on what these things mean. Catherine, you've got a deep background in smart cities, a lot of time spent at IBM and now at Meshed. You've obviously seen this mature over the years, but take us through how to think about the term IoT, Internet of Things. What is a thing? How should we think about it?
From my perspective, it's pretty simple. Anything that can communicate to benefit an outcome can be encapsulated into the Internet of Things. And, for people who've been in the asset management and city space for a very long time, it's kind of just the new look of telemetry, the ability to get data from a distance and be able to see that, at your fingertips. And the great thing is that we are living in an era where 3 amazing things happened all at the same time to make this so affordable. We had miniaturization, so the ability to actually manufacture components at really small levels, such as chips. We had the growth of the cloud, so to be able to serve data remotely instead of on-premise. And then the other thing too that we had is this evolution around open standards, the ability of in the communications industry to have connections created through more of an open standard from a technology perspective. And so that's what has really, I think, driven the popularity of the Internet of Things. And just a quick survey, how many people here have got a Google Home or a Nest or something like that at home? Right. The best I use my thing for is trying to work out the timer in my oven because I still haven't worked it out. But, you know, what I think we'll see is that smart home concept really starting to expand out of the building into the precinct, into the city. So I think that's really nice time that it's all coming together.
Sort of mental model I've developed more recently is there are certain things that we've always wanted more information about that we haven't been able to get. For example, we're working with our friends up in Cherbourg who have a material recycling facility. And one might look at the waste flowing through a material recycling facility and see waste, but one might also look at it a different way and see data, because there's an enormous amount of data there that we simply haven't really had the mechanisms to collect up until now. So the things you're talking about are really connecting sensors to whatever it might be, everyday things that throw off data for us to be able to then make better decisions about.
Absolutely.
Excellent. Paul, sensors, you have an amazing catalog of these days off-the-shelf sensors and obviously are aware of lots of innovation going on in the space. Take us through how to think about sensors, perhaps a couple of examples of from various ends of the spectrum in terms of simplicity and complexity of these things.
Thanks, Chris. Yeah, you're right. There's a huge acceleration in the availability of different types of sensors. When we first started Meshed 5 or more years ago, we had about 3 sensors that we were able to put in front of customers. That's now in the hundreds, if not the thousands. So having that open environment has really helped to turbocharge the development of the whole ecosystem. To address the question about ends of the spectrum, we've got little accelerometers the size of a matchbox that run off 2 AAA batteries. But they're not simple. They're actually quite a sophisticated sensor, and they can sense tilt and angle, and they're good for, you know, things like putting on park benches so that you can tell if someone's sitting on them or not. Just minuscule changes in the angle of the seat can be measured, or you can put them on an RV dump point to figure out how many times it's been open and shut. You know, and they're quite cheap, $100, maybe $200 max for something like that. And then right up to the other end of the spectrum, you've got really highly sophisticated scientific devices. We're working with a company called ICT International, who you'll hear from later on the panel. They're environmental monitoring specialists. I know that they're working with some of the councils up here in Southeast Queensland, and they're doing really sophisticated water quality monitoring with sensors and probes that go into the water and tell them various things about the quality and the state of the water. So it's a pretty large spectrum, and you know, we're talking about $4,000 or $5,000 plus for some of those sensors. So there's a whole spectrum and price points and sophistication levels from way to go.
Fantastic. Catherine, LoRaWAN is a concept which is probably quite new for most people. Talk us through LoRaWAN and perhaps juxtapose it against, say, other networking technologies people might be more familiar with, cellular and Wi-Fi.
Great question. So for me personally, I came across LoRaWAN when I was in IBM back in 2012, and a colleague of mine, Nicholas Sornin, had invented the LoRa standard. He was working at the IBM Research Labs in Zurich. What he was trying to solve with LoRaWAN was the ability to have a ubiquitous open standard for low power, so not to drain batteries, because that's the challenge with cellular and Wi-Fi devices. They need a lot of power, and long range. And he was trying to apply this in the gas industry in Europe with gas meters, because they were looking to metering. And so the LoRa, it stands for low power, long range, that's the LoRa, was then encapsulated into a wide area network standard by the LoRa Alliance, and that happened around about 2015. And essentially, where does it fit? At the time that when LoRaWAN came into the market, there was also another low cost, what we call LPWAN, low power wide area network, called Sigfox, and that was developed very strongly around Europe. But at the same time, all of the telcos were looking at planning for their version, the cellular version of IoT, being NB-IoT and CAD-M1. And I think what we've seen now 5-6 years in is amazing maturity and understanding that LoRaWAN has its benefits because it's a fit for purpose technology. It's a technology where if you don't have great cellular connectivity, you get that last mile of connectivity. but it's very low data rates. So it doesn't support video and voice or higher data rate applications. I think it's extremely complementary with where we've seen now NB-IoT and CAT-M1. Now we're starting to see LoRaWAN being the largest decentralized IoT network in the world. And that's because when LoRa was invented, the company that bought the technology decided to release it as an global open standard. So that meant any manufacturer could take the LoRa standard, they could manufacture the chip, and then they could release it to the ecosystem. So I think that's also a great benefit of just the portability. And we're certainly not going to advocate that it's one or the other, because what we're seeing in our business is so many opportunities and occasions to run LoRaWAN in concert with cellular technologies such as NB-IoT and CAT-M1.
Right, thanks. I guess the low power nature is so important. We think of some of the use cases we'll hear about later, parking sensors and things like that really need very long battery life to keep the total cost of ownership low.
Yeah, and the key kicker here is, Chris, LoRaWAN doesn't require a SIM. So the ability to have these sensors and multiples of them with having to manage SIM is a key advantage.
Massive.
Of the technology.
Let's wrap it up, Paul, with the Things Network. We're going to be hearing from Vinky Giesman, the founder or co-founder of the Things Network. But just from your perspective, tell us about the Things Network. Many of the attendees today are beneficiaries of it and using it, but just a very quick kind of summary from your perspective of what the Things Network is.
Okay, try and boil it down. It's a very disruptive telecommunications network, and it's disruptive because it's free. It's not free for the people who are putting it up because it's built by its own users. The way that IoT works is that a sensor sends a transmission and a gateway grabs it and sends it onto a network server, which is like a traffic cop in the cloud, and sends the data onto your application. Now, what's unique, I guess, about the Things Network is that server in the cloud, anyone can use for free. So what that means is you can take a IoT device like a water meter or a people counter, and you can register it on the Things Network at no cost. When the server sees a transmission coming from that device, it will just pass it on to you at no cost. So that removes a huge amount of the barrier to adoption. And councils have been very enthusiastic adopters of this technology because they see it as community building. The role that Mesh plays in this is that we help the councils to procure the hardware and the services and the expertise to put up the networks. But once they're up, everyone can use them for free. So that's the power of the Things Network. And we think it's going to turbocharge, and it is turbocharging the adoption of IoT, and therefore the adoption of all of the insights and benefits that come from IoT.
Fantastic. Thanks very much, guys.
Thank you very much.
Much appreciated. A lot of you might be wondering, why is little old Noosa talking about all these highfalutin technology terms and what's our interest in it? I thought I'd just quickly contextualize that for you. So 2 years ago, almost to the day, this little town, including this digital hub, nearly burnt down. And that gave us pause to think about how could a digital hub in Perugia Beach make some kind of contribution to helping regional communities like Noosa deal with the sort of existential threat of bushfires. After quite a lot of research and discussion, we found that one of the major challenges is the adoption of promising technologies, including some of the smart technologies we're going to be talking about today. So we headed down on that journey, and that took us down the path to creating a program called FireTech Connect. FireTech Connect is an effort to really create an ecosystem around bushfire resilience technologies and ultimately create a center of excellence here in Noosa to help advance and commercialize that technology. We're doing that by providing a platform to emergency services agencies, utilities, and importantly, LGAs who are concerned about bushfire resilience in their communities and who want to get access to the latest and greatest technologies to help protect and build resilience in their communities. So the way we do that is by providing a pilot trial platform, because we figure the thing that is very difficult for these organizations to do in terms of adopting this technology is prove that they work. It's difficult to prove that a bushfire detection technology works without a fire, for example. So providing a platform that enables us and partners to run pilot trials of promising technology is what we're doing. And this connects to this question of smart technology. So we're in the process of establishing a living lab, which really consists of two pieces, a bushland lab where we have established a LoRaWAN network, a camera network, etc., that will help us trial promising technologies, and a big data lab, which we're currently constructing, that will enable us to visualize and make decisions around these kinds of data points. That involves putting up gateways, much like Paul and Catherine told us about, across the Noosa Shire, that will allow any of our community members, technology companies, the council itself, to be able to deploy this technology, deploy sensors, collect data, and make better use of them. These are dotted around the Noosa Shire. We've been trialing various locations to figure out what the best coverage is, and seeing very, very positive results, reaching as far as 60 kilometers in some cases from a gateway out to where devices are able to connect to them. The sort of things we're interested in and we'll be trialing, and I hope that the next time we do one of these conferences, preferably in person up here in Noosa, the sort of things we're interested in that are highly correlated with bushfire resilience are things like microclimate, soil and fuel moisture, detection of bushfire using gas sensors, and then finally understanding the movement of people and transportation and traffic from the perspective of making sure that we have strong evacuation strategies in place. That's just a quick glimpse of our sort of vision for our data lab in the future, which I hope to give everyone a tour of around this time next year. And the call to action here really is, if you're an LGA that is facing a bushfire threat and you're interested in collaborating, please jump on firetechconnect.com, connect with us, and let's see how we can work together to trial and accelerate the adoption of some of this exciting technology. All right, that's enough from me. I'm now going to hand over to our overseas participant, Vinka Giesman, who is the founder of the Things Network, and is going to tell us a little bit about the Things Network, how it works, and give us a global perspective on the sorts of things that are happening around the world. Let me just make sure I get this right.
Hello, my name is Vinka Giesman, CEO and co-founder of the Things Industries and the Things Network. And I'm going to tell you a bit about what we do, what kind of problems we're solving, and what our vision is. And I do this through a pre-recording because I think currently, probably when you watch it, I'm already asleep because I'm from the Netherlands, Amsterdam in Europe. So thanks for having me for this short introduction. Thanks a lot for Mashed with Catherine, Andrew, and Paul for arranging this talk. So let me just dive right into it. What we do as a company, as an organization, is that we help companies around the world be successful with building large sensor networks. And we do that literally anywhere across the world. And we have a somewhat of a unique model where we have an open source business model where we have an open source community of now 150,000 developers that we, through an open source and open tools, help to build successful applications. And once they're going to scale, we help them with our business and an enterprise context with the Things Industries. Basically, what is LoRaWAN, right? That's the technology we're going to talk about, and you're also going to hear about more today. And basically, in one sentence, in one tweet, LoRaWAN is a wireless technology that's used to transmit small pieces of data over the air over a large distance without using much energy, so you can run sensor devices on a battery. So this is the technology part. So what it enables is a huge amount of different applications. We see that what you here see is a set of devices. What you can see, for instance, here in the top is a mousetrap. So for instance, they put LoRaWAN technology in mousetrap, so they can send small signals to, for instance, notify when a mouse or rat is caught, and then you can replace the mousetrap, having immense cost-saving opportunities. Another thing you see here, for instance, where it's used, is as a smart parking meter, very well known also with what Catherine and Andrew do in the smart city context. Is that like you see, there's a round black, more like a puck, where there's a battery, and when a car drives over this device, it will send a message and will notify, for instance, if a car is parked in the wrong place or if it's occupied or whatsoever. And for instance, see also all kinds of weather applications it's used in farming, but also applications that just send telemetry and simple temperature sensors. So our systems are working in many fast food restaurants across the world, where they measure the temperature of, for instance, the fridges, and this temperature is used for the operations and for food safety. So pretty awesome technology, a very large amount of business cases that are enabled because this new IoT technology is here, and we provide that as a platform and an easy way to start developing these kind of solutions yourself, or we help you scale it. So just to dive into the technology for ones that are interested, the techies among you. So what I said is also low power. It means that, for instance, if you have this parking sensor, you don't need to charge it every, let's say, week, but it actually can last on the battery and be fixed to the ground as a parking sensor, and maybe can last up to 4 to 5 years. It's very long range, and that's very convenient. You don't need to have a receiver that's very close. So this network works where you set up gateways that are basically the receivers. You can compare it to a Wi-Fi base station, or for instance, one of these 4G, 5G towers you see around in the city, but they can be placed actually quite far away from the sensors. It can go into buildings and through walls with indoor penetration. It's using a free spectrum, and this is pretty interesting. Just like you don't need to ask anybody to set up a Wi-Fi base station. This is the same. You can build this network yourself, and what we see now is that a lot of people building these private networks. There's even some geolocation and some ranging features in it. This gets me very much into detail. And you can build public and private networks. So you see that some operators have built LoRaWAN networks, but they are interoperable with building smaller networks, and they don't interfere. They actually complement each other. Very interesting about this technology. The end-to-end encryption is in the protocol, of course, for IoT, very important, as well as firmware over-the-air update. There's a very large ecosystem, and it's a lot of like device security around certification, and there is a massive ecosystem. So LoRa is everywhere. I just gave you some examples. We built LoRaWAN on these kind of ships, where they built, for instance, sensors that measure these ventilators you see on the top of this ship. We help, for instance, the German railway organization by building networks for the railway stations, and we're using this, for instance, for an application to sync the clocks. We use it to monitor industrial kind of systems, and by measuring the vibration, or the developers that use our platform can, for instance, detect differences in vibration that, or maybe detect things that go wrong. Industrial kind of sites with even temperature, humidity sensors, and this is our partner. They use that in a museum where they measure the temperature, humidity, and there's actually certification around, for instance, artwork that needs to be conserved in a certain way. They picked a very good name for that. For instance, we're working with retail companies that work for building alarm systems and all kinds of telemetry systems inside of retail stores. So this is, for instance, for phones. Here's what you see is in elderly care, for instance, sensors that measure all kinds of activity in elderly care to make sure that they can still stay at home, but there is just sufficient amount of monitoring to see, okay, is everything going well? One of our customers is WeWork. You might have seen it. They use this for sensors inside of meeting rooms, and inside of these meeting rooms, they detect how many people that have been there, and then they can build also kinds of analysis around how they design these offices. Same for a customer called Spacewell. They build these systems then for other, let's say, co-working space companies. We have many customers that do cow tracking kinds of applications, and basically it can, here you see an application, and you can actually see they detect, for instance, bull performance, or they detect with cows when they are pregnant, etc., etc. Yeah, so we have many customers that do that. We see in agriculture that, for instance, here this is in Scotland, that associations or organizations of farmers or government organizations, they actually help farmers innovate through joint efforts, and more when, because the networks really are able are really easy to make interoperable. You can build, let's say, these networks together. Here as well, air qualities use cases. This is a company that we're helping, and they're mounting fridges in hospitals. I just explained to you about the mouse trap. So basically, there's this ton of applications, and if you dive into this technology, and even we, after 6 years, get surprised every day by somebody figuring out something to do with this wireless technology. And of course, we invite you to do the same. So who are we? When we started the Things Network, we saw a few things. We saw that it's extremely hard to be successful with IoT, because you have the devices, you have the network, you have the application. So we thought we need to enable the developer ecosystem. We need to make developer tools, and we need to make sure that it's really easy to get started. So that's what we call 0 to 1. That's what we do with the Things Network and our open ecosystem. And we have a lot of great tools and sets. And what we do with the developer ecosystem is that in this ecosystem, all these people are building these networks to test, and also they're connecting them all together and building this global network now. With the Things Industries, we help you to scale. So we help you with operational support, hosting, and SaaS. We have extended developer support, and it's also great to mention that we have partners all around the world that actually help customers even better with our software. So, for instance, an example is Meshed. Catherine and Andrew have been a long-time partner. It's great to working with them. Also on the business side. So this ecosystem started growing and growing and growing when we set out this vision 5 years ago, and these networks started to emerge. And what we created is a system where these networks and these gateways that you set up to build these IoT, long-range IoT networks, start to work together as one big network. So the ecosystem started growing to now 150,000 developers. We have now around 1 million registered devices all around the world. We have operated around 40,000 gateways that are supported by our software and all our systems. And we route around 800 messages a second all around the world. So if you go to the thingsnetwork.org, you can see more detailed mapping, see exactly what's happening. But this network is growing from the bottom up, and because it's supporting all these different use cases, and these networks can have this massive amount of utilization. We see this growth happening. If you look at the market, of course, we're not the only one that are doing it. There's a whole market here. And you see that these are a bit of the predictions in millions that goes around. I am always very cautious to believe any IoT analyst, but the only thing that I can at least agree with the analyst community is that there is this exponential growth phase, and it's really finding traction. What we do around the world to enable and help the ecosystem and educate so that we get more IoT success is that we do conferences. We have one big conference every year in Amsterdam. We're going to have one again in 2022, January. Of course, We skipped 2021. Luckily, we could do the 2020 January edition. And we have always a yearly event in Hyderabad. We had last time in Australia, we had one in Adelaide, we had them in Japan. We now have them all around the world, and these gatherings, they have been always very, very successful. As I said, there's a huge amount of devices. So there's already a lot of devices out there. So if you have an idea and you think about something, go talk to Catherine, go talk to Andrew, and just brainstorm a bit. And probably if they say, hey, we probably already have a device for this, you can find it literally anywhere. It can be used in a lot of different contexts, from agriculture to buildings to ships to warehouses to industrial. Really, it can work anywhere. So yeah, want to keep it short. I want to thank you very much. Again, when you want to get started, go to thethingsnetwork.org or get in touch with Andrew and Catherine. And if you want to know more about scaling this as a business, then you can go to thethingsindustries.com as well to see what kind of solutions we have there. And I want to thank you very much for your attention, and enjoy this event.
It said that there was no such thing as building a better mousetrap. And I think we just witnessed that there is such a thing as building a better mousetrap. You just simply have to add the internet to it. So if anyone ever tells you, anyone ever uses that idiom, just say, hey, whoa, stop. I've got just one example of the better mousetrap. Next up, I'd like to introduce our neighbors to the south, Michael Werrett and Toby Cluett, two of the forefront, or two thinkers at the absolute forefront of smart cities here in regional Southeast Queensland, and who've been very, very generous about sharing knowledge, sharing their understanding of this technology as it's evolved. And we've learned a lot from them already, and are collaborating closely with them. Please welcome Michael and Toby. Just one sec.
Okay. Thank you, Chris. Thank you to the Brisbane Digital Hub. Thank you to the Noosa Council and Mesh for putting this event on. It's fantastic to be able to bring our collective story. Probably 5 or 6 strands that we could talk about if we had enough time. But today, our core objective at Sunshine Coast Council is about getting IoT to inform data-driven decision-making. And as I described to somebody before we started, if we can't help individuals in the organisation make better decisions and become more efficient, if they can't do that with the data and the pipeline that we produce, then we've failed. All of the other things that we do to get there are necessary, but if that data is not helping them make those decisions, it's not working. I just want to run through, Toby will join in a couple of minutes around some more detailed components, but I just want to talk about our catalyst on the Sunshine Coast for smart cities. 2014, Sunshine Coast Council was building on a golf course, a new city centre. And a key objective of the group that were doing that was how not to build a 1980s, 1990s city centre, but actually one for a digital city in the digital century. And so we focused on hardware and the kit that is actually there and live today. Smart poles, originally the 55 that were there, and some trials in Bulcock Street. We now have them in 11 or 12 locations across the coast. We have them in 3 or 4 more planning locations and several more in design. our digital kiosks, our vacuum waste system, a novel approach to actually removing waste from a city centre, but also what happens underground is just as important, the pits and pipes, and then the switchboards that integrate those connections to the external area. So we've done all of that kind of work and growing. In 2014, Telstra and Cisco helped us with the development of a smart city framework. And there's a lot of components in the 89 pages that council adopted, and we're preparing to do our next version. But I found on one of the core pages, and it's reflected several times, that data will support improved decisions, real-time bus location, conservation through optimisation, predictive maintenance, informed capital works, and responsive lighting will serve the precinct. Now, I've taken and adapted the text that we had there, but for me, it's really grounding that exactly what we're working on today in detail was reflected in the document that was adopted by council. How we're doing it is really about understanding measured insights for us equals informed strategy and policy decisions for council. Near real-time information equals improved performance in service delivery. And if any of you would like to read the Queensland Local Government Act, a couple of the key priorities right at the very top that drive our thinking is our objective or responsibility as local governments is to improve performance and improve efficiency. There's several other things, but I'd take that and bring that into what we do. Urban measurements equals data-driven design and placemaking. Asset performance measurement helps capital work spend pattern. Sometimes it brings capital works build sooner. Sometimes it stretches it out. Both ways are about getting better outcomes from our money and our ratepayers' costs. Accurate counts and trends are about improving, for example, grant application details. Councils need to get grants from the state and Commonwealth government, and so doing that's important. 3 steps, our sensors, connectivity, and then the data-driven. But for me, we go that step further about how that gets to people and in their hands. So I'm just going to give you some examples of some sensors from Meshed and also the ARCS group that are currently our key vendors as a result of our RFQ that we ran earlier this year. And we're really pleased to be able to say, compared to some of the bigger carriers and other vendors, the pricing that we're getting, it does cost us, but it's significantly cheaper. And so all of the things that you've heard already this morning, we've measured and continue to measure those benefits. But then when you drill down to a sensor or a group of sensors, and these happen to be in Woombye, and I could talk to you about all of the bits and pieces that you see on the screen, but in a little rural town and a railway line location outside the spa there, and I asked people, how many times do you think vehicles come in and out of the parking bays? And usually they might say 15 or 20. The reality is we're seeing 60, 70, and sometimes 80 times a day, those parking bays are being used. Further down the street where there's some consultation occurring about the use of that street and putting another pedestrian crossing and a speed hump to slow movement in the town, we can show that they're only being used 20 to 30 times. And so direct consultation can now occur with those actual businesses. We have just switched on turtle nest temperature sensing, which is a really exciting way at 50 centimetres underground, which is the depth of the turtle nests. Council has been doing this measurement for over a decade. It's part of the leading groups that have been doing it. The problem is it was only accessed retrospectively at the end of the season, which is about now. So the sensors were dug up, connected to a computer, and the data collected, and it was retrospective. Really good stuff. But what you can see on the screen is something that I literally was able to grab off the dashboard. It's now real time, near real time. It's got temperature. It's also got humidity at that depth, which is the straight lines, green and yellow. And it's accessible to the turtle groups as well, the volunteers. So making data accessible is really important to them and how they do that. Diving to something completely different, barbecues. Council has hundreds of them across the region. And the 3 of the 5 that we've currently just installed aren't used very much. And we know how little they're actually used in the last few weeks that we've had them installed, because we're seeing it. We're now getting data in near real time, the total hours used, the number of uses. We can see every time that button is pressed. We know exactly how much energy is used. And that is helping the staff in the planning area of parks and gardens to be able to determine how many barbecues should go in that area and how we invest. And when they actually replace those barbecues with new ones, they'll have data sensors in them, giving them that information moving forwards. So they can show the prior and then the afterwards. So you end up with the time series information. I could go on about heaps of other live ways that we're using data. Urban heat islands is something that a number of the speakers today will cover, I'm sure, so I won't talk about that. The use of thermal image cameras at an urban scale to be able to provide temperature sensing. Building management systems. Our gateways that are run with solar have a building management system applied to them. We can see, and the example I use is one that when Woombye was installed with a solar system, we had a problem. It's up there on the screen. We could actually see that there was something wrong with it. And there's 4 other screens that actually come with it. But this one actually allowed us, with our electrician, with our vendor, to actually identify what the problem was. The wrong kind of solar panel was applied. It was a 12-volt regulated one, not an unregulated one. We went through, and now we've got sinus rhythm with that. We use water meters to do the same thing and give us details about leakages and performance and understanding, and being able to check that Unity Water is charging us the right amount for the amount of water consumed, which is another good thing. I'm going to hand over to Toby now to take you through a more detailed dive into the way in which we actually take individual sets of data and turn it into items of data of more value or specifically valuable. Is that? I'll leave that to you. Over to you, Toby. Thank you.
Yeah, I'm going to talk to you today about connectivity and analytics and visualization. And I like this slide because really with this infographic that's from Domo, they produce it every year, talks about the amount of data that humans, and other aspects of society are using data across wireless networks. And you could look at all the details in terms of the data. I was going to use a pointer to actually point some of them out, but bottom left-hand corner of the screen, 4.5 million searches from Google every minute. This is every minute of every day, in 2019, but they produce this graphic every year. This is 2 years old already. Over on the right, 188 million emails a minute. And up top, Netflix. They've got it in hours, but essentially that's 46 million minutes of Netflix being viewed every minute across the planet. So that's a lot, that's a ridiculous amount. And in stark contrast, you've got the IoT sensor, and we saw that number, 800 a second, which actually is 50,000 a minute. In terms of IoT sensors across the globe on the LoRaWAN network, it's a huge difference between those two. And so really this stark contrast between the amount of data and the rate or the cadence of data is why there's such a significant opportunity in terms of our communications networks. And I can see over here from Catherine, it really is a massive gulf. And I'm a numbers guy. I like analytics. Michael can attest to that. I like getting really deep into the patterns that you can see, and I'll talk about that in a moment. But there's a huge difference in IoT devices. Essentially they're optimized to operate over a long range, tends to, like in our case, we've got Glasshouse Mountains, and so we're seeing 60 kilometers in terms of received signal from a little device that's just going every minute and sending out a really low-powered pulse, and we're collecting that information and across all these different sensor types. And Michael's spoken about the types that we're using, but these are some of the quantities or the breakup of different types of sensors across the globe, and they're all emitting just really small pieces of information. And that's really valuable over time. In terms of the connectivity on the network and getting a better understanding as we roll out our gateways, we're testing in the, like sort of the forested environments, and you can see, you know, here it is. We've got an oyster tracker, and that essentially says, this is where I am. It's an IoT device that says, this is where I am. It just says that continuously, and there's a gateway on top of this building, so it's definitely getting through. But when you drop out of range, you don't see the signal, and so it gives you an understanding of how good your network is. And so you can see on the 2 images on the left, sorry, yeah, on the right, you can see that where the signal is getting through, you can see those dots on the map. You know, that's actually the signal getting through. But you can see where I've walked, and I've just used my GPS and my phone to record where I've walked. And sometimes it's getting through, sometimes it's not. And this is really helping us. Stick it on a garbage truck from our contractor, and essentially it goes everywhere through all of our suburbs, and we can tell which suburbs are being have got coverage and which ones don't. So that's really helping us. Another thing that's really helping us in understanding how we're going to be able to service our customers internally is modelling. This is my bread and butter, geospatial modelling. So we use the bare earth model to essentially model from our gateways, which is those little green stars, where we're getting to. And you know, you can see on the left-hand side there, the coastal floodplain. It's flat and it's got a whole heap of glasshouse mountains that stick up. You know, you put you know, at high positions along that coastal floodplain, you get really good connectivity, and that's what we were expecting. But then on the right-hand map, you can see this oyster tracker, all the bits that it's picked up over the last 6 months, and that's really the length of time we've had a significant number of gateways deployed. You know, where the signal's strong, you know, we're getting a green signal, and where it's dropping off, but still getting through, we're getting a red signal. And so it really helps us communicate to our clients if they're actually going to get signal for their particular application. I want to put 60 sensors out there doing this. Am I going to get the signal through? It's really helping us understand that. I think I've got a minute left, so I'm going to fly through. But really valuable information. Buildings and vegetation, as well as the ground, impede the signal getting through. So for connectivity, we're using LiDAR data, and that really helps us in complex environments. You can see here Woombye. It's in the hinterland, and we don't get signal everywhere, and we need to know where we're going to get it. And so we're using that type of data to model where the signal is going to get through, so we can understand if we can deploy sensors to a particular area and have success. Moving on from connectivity, and this is the integration piece. On the left-hand side, you've got in orange, you know, like all the sensors and what they're picking up. Through the middle there in pink and red, you've got communications. Really important layer in terms of integrating and getting your data through is this middleware. So it's something we've found, something that's a challenge inside our organisation with lots of different silos and technologies, is get some standardisation for your middleware so that you can get your data into your database and let people discover it and use it. And at the other end, in blue, you've got applications. And that's what I'll talk about now. Get your data into your database and visualise it. And as an analyst, I know that I need to be able to see the data and see the patterns in it. And for us, the tool that we're using in terms of being able to visualise our data, you know, Power BI, you know, it's like the next Excel and the next Word. It'll help you actually, you know, visualize that data and see the patterns. And, you know, a really interesting scenario that we came across is essentially, you know, irrigation. How much water are they using in different months of the year? And what we found is after digging into the data, there's a really simple metric that we could use, and that is the scheduled runtime versus the actual runtime for all of our data. And you can see these patterns in once you actually visualize it. And it helped us then produce a dashboard where that simple metric underpinned what we were trying to communicate to the people managing the parks, and the people managing the budgets for the amount of water that we're using and the number of resources we're deploying. And so really simply, last slide, 15 minutes, you know, this ability to discover your data, making sure it's connected, make sure it's in your databases so that you can see it and find it. Look at the patterns, so explore it yourself, and the analysts and the subject matter experts, and then figure out how that pattern can apply to a decision-making process that you have. And that's really the model that we're using. And on that note, thank you very much.
Cheers, thank you. Why do you give that to James, please? Thanks very much, guys. We're moving our way gradually south. We started at Noosa. we went down to the Sunshine Coast. We're now going to Moreton Bay, and then we're going to go to Brisbane, and then we're going to have a coffee break. So without further ado, let me welcome James Peat to come and share some of the fantastic case studies that we're seeing out of Moreton Bay. James, please welcome. Please join us. To your slide. There you go.
Thanks. We're looking at. Is that the camera? Where's the camera? Is that the one? Right. Hi, everybody online, and hi, everybody in the room. My name's James Peat. I'm the Chief Digital Officer for Moreton Bay. Thanks to Noosa Council for putting this event on. I think it's just excellent for us in this local area to be able to get together, but also to share that via Zoom with all sorts of others. So today I wanted to talk with you about our journey so far. I'd like to also thank Steph, who's joining us today, who's in the team. There he is. And in our small team, which is myself and Steph, run the Smart Cities at Moreton Bay. But also Michael Werrett from Sunny Coast that just presented. Michael and I have worked together and collaborated over a number of years. And Michael, you're sort of been quite inspirational for our journey, so thank you. So I'm going to talk today just about our journey so far. I want to concentrate on, I guess, where we are today, and I think where we need to head. So I'll just sort of lay the groundwork first of all. And if I press this button, excellent. So the way we do, I guess, smart cities at Moreton Bay, we don't actually have a smart cities strategy per se. But what we have is these 5 strategic pillars that run the whole organisation, and I participate in a group where we look horizontally across all of these pillars to understand where are all of the, I guess, the digital points, where are all the things where digital can benefit and enable these strategies, and so we have quite a broad, I guess, scope of what we're looking at. Now we know that smart cities are enabled by the Internet of Things. And what I wanted to do is just quickly run through, I guess, where we're seeing that. So first of all, the things, and this looks very familiar, doesn't it, to what Michael just presented, but I'm assure you I didn't pinch it. Just happens to be true. So things collect data. The data needs to be transferred, connected. We need to store and analyze the data. And then in order to make things better, that's something I learned from Adam Beck. It's a great way of just expressing what we're all about and how smart cities can take us. So firstly, things. There's a thing. That's a NetVox temperature sensor in captivity on the desk. And when I press the button, nothing happens. Third time lucky. Here we go. Here it is again. It's actually installed, and anyone with an eagle eye will might see that it's actually installed incorrectly, and I'll let the mesh crew tell me how that is. We've got, did I just miss one? No, I didn't. Okay, smart lights. Press the button. Smart parking. Sorry, this wasn't supposed to be quite so slow, but here we go. Here we go. That's a camera that's attached to our e-bike that's ridden around all of our footpaths and automatically picks up all of the footpath defects. It's the same camera that we're running in our garbage trucks as well to capture all of our road defects. Smart Barbies. We've got various smart sensors of different kinds in our hub. Smart poles at Peachtree Mill, water quality monitoring systems at Capestone Lake, and there's many more. So what happens then? So you need to connect those sensors, typically wirelessly, but not always, so that you can bring all of that data into mission control. So we've got a few different IoT networks in our region. We've got Sigfox, which is the top right coverage map there. On the left-hand side is the current state of our LoRaWAN network. And the bottom right image is the LoRaWAN gateway. And we're probably pushing LoRaWAN out quite a lot at the moment as it supports various projects that we're working on. Also across our region is NB IoT, which is being deployed by the telcos as we go along. So also, it's not just wireless, and we're looking at how we can use, or how council can start to assist digital connectivity across our region by building our own pit and pipe networks. So that's the pit and pipe network at Petrie Mill, and that's a photo of it at Petrie Mill. It's not very exciting, it's just under the ground, but it's actually incredibly important that we consider also fixed connectivity and how council plays a part there as well. And then you've got all of these devices, you've got gateways, you've got networks. So now we're at a point where we have about 700 devices in the field. And with all of those devices, they're all sending data in our direction. How do we deal with that? How do we get benefit from it? How do we make things better for the community? So storage and analysis. So what you see there is one example of one sensor at a moment in time. That's a payload. And that particular sensor is actually one of the movement sensors on our smart lighting network along the Moreton Bay Rail Link. And it's telling you that somebody's walked past that sensor. There's a lot of data in there, and that particular sensor, I think it reports in every couple of minutes. You've got other sensors that might be every couple of hours. You've got other sensors every couple of seconds. There's an avalanche of data heading in our direction. And so how do we deal with that? This is how we deal with that. This is our Smart City Data Platform. That's a picture of the components that make up the platform. But it's a couple of the important things to note in this particular diagram. The light green on the top left, that's ingestion. That's where we're actually taking data from the sensors as it arrives through different methods. There's lots of different ways data arrives, and we need to account for those ways. Now, that data ends up in our data lake. But also on the top right, that blue area, there are our systems of record. So we use Technology One, we use Esri, and we also have a number of other systems such as Tritium Niagara for our building management and a few other things like that. So it's very important that we position this right beside everything else so that we can integrate with everything else. So putting it all together, how do we make things better? Now, I like this particular quote. It's been around for donkeys, but really it describes quite easily what's happening certainly inside Moreton Bay, where there's different teams are innovating in different ways, and we're seeing some really amazing things, and other teams aren't. But then you multiply that across, say, all councils in Queensland, Australia, and around the world, where you've got lots of different things going on that are really solving problems well in one area, but another council who has the same problem, they just aren't solving that problem. So there is an unevenness. And so how do we get it more evenly distributed? So what we're looking at is, well, where are we and where do we need to go? So I did this self-assessment of our progress. In terms of things and connectivity, we're going okay. In terms of storage and analysis, I've got that sitting at about 40%. Steph reckons it's higher than that. I tried to change it, couldn't make it change. So my PowerPoint skills clearly need improving as well. And then making things better. We have moved on a little bit since I did this particular slide, but that helps us understand, well, where we need to look. Now, this is a framework. There's lots of frameworks around. The reason why I like this particular one, and I found this one last week whilst Googling, as we all do, but what it does is it really helps articulate our current thinking about where we need to head. It's all about analytics. And you've got three categories. You've got hindsight, insight, and foresight. So I just wanted to run through, I guess, some of the examples of that and where we need to move on. So examples of hindsight, of course, anything that's historical. So this is the water quality monitoring system that you saw on the photograph earlier of Capestone Lake, and that's a dashboard. Another dashboard is John Scott Park, where we've got lots of different devices coming in from the park, and it's helping our Parks and Rec team and also our operational teams to manage the park better. It's not a particularly exciting dashboard, it's just giving you graphs of stuff, but we actually want to use it a lot better than that. Another one is the dashboard that Enerhub are providing to us as part of our Petrie Mill implementation of their smart infrastructure. Again, hindsight. Then we move to insight. Now, I guess there's a couple of examples from an operational perspective. When is a thing true or false? So in this case, when is, and that graphic on the right is our water tank measurement system. When do people congregate, or where do people congregate in our parks and our libraries? So getting insights around really what's going on. Technical insights. In fact, that's talking more about the way we are doing our smart city projects. By doing small projects, we get insight as to how that project can assist us. We're doing these projects and developing business cases through the course of that project to further scale things up. And then commercial insights, understanding what is the value of what we're getting when we go and spend X number of dollars on a parking sensor, for example. We don't actually charge for parking in the Moreton Bay region. We just, book people when they overstay their welcome occasionally. So we actually don't have much of a business model around parking control systems, because we're not making a huge amount of money out of parking. So anyway, I won't dwell on that, but certainly we want data from our parking systems as opposed to, I guess, revenue generation, and what's the value of that data. So planning insights, what are the, and longitudinal data is a really important thing. So no more are we sitting in a park with a clipboard occasionally. We're now getting longitudinal data every couple of minutes. It's telling us what's going on. So we get to see patterns of seasonality, outlying events, and start to do predictions of what will happen in the future. And then organisational insights, as you've seen, dashboards showing what's possible, and then gradually understanding that there's things that maybe we knew, but actually the dashboard's telling us that we don't know. And also finding out things we didn't know at all. So there's interesting things there. But now we get on to foresight, and I think this is the important one and the most exciting one, because this is where we're starting to impact in real time or predict what's going to happen in the future. So what you're seeing there is our a business rules engine. Well, it's actually not the engine. It's a picture that describes what that engine does. And as you can see, we're looking at the water quality, we're looking at the tide, we're looking at the weather, and from that we're determining what potentially could be happening. And then we're saying, turn on the pump. So we're going back out into the field and making a change to change what the future was going to be. The future was going to be a fish kill, but now we're able to say, hang on a tick, in 24 hours, the likelihood is there's going to be a fish kill. Let's turn the aeration pumps on and deal with the risk that's presenting. Another one here is another rules engine for our smart lighting system along the Moreton Bay Rail Link that ARCs have provided to us. And it's simply saying when somebody walks past a light, make it bright, 5 minutes later, dim it back down again. So these are things where we're starting to actually impact on back in the environment in positive ways. So how do we really move on, and how do we get to that? Because there's a lot of those kinds of ideas, but really starting to scale them up and make them happen is all about data leadership and culture within our organisation. And that's a lot of work that Steph is doing in the team, is really starting to advocate the use of a smart city mindset in solving council problems. So building a culture and connecting across the organisation to help everyone understand that there is a different way of looking at this to solve the problems that we've always needed to solve. Looking beyond just efficiency, but also look towards outcomes. It's not just about saving money on everything. It's about being able to provide a better service, potentially with no external, no extra expenditure. But also, are we asking the right questions? So rather than looking for answers, the data is helping us to say, actually, there's other questions that we could be asking here. And then collaboration. We're really learning that the silo mentality kills innovation. Collaboration makes innovation happen. So we're doing a lot of work in that space as well. And all of it so that we can make things better for the community. So that's sort of where we're at. I think that's my last slide. It is. So thanks everybody for your attendance and attention. And I'll hand it over to the next person.
Thanks, Jim. Cheers. Thanks so much. Rightio. One more presentation before coffee break. We're going to ask Derek Meggett from Brisbane to join us. Brisbane, of course, still in the afterglow of the Olympic announcement for 2032, and I think you're going to hear some exciting use cases around how Derek and the team at Brisbane are thinking about how smart technologies are going to play a role in the lead up and during the Olympics. Please welcome Derek. You're ready to rock and roll.
Hello, everyone. Thanks to Chris and Deirdre for hosting, for the sponsors, for the guests that have spoken beforehand, a lot of local collaborators. Yes, while Brisbane may have, let's say, been awarded the 2032 Olympic bid, it's not just Brisbane, it's Southeast Queensland. In fact, it's much more broad than that. There's a few slides and a few conversations that have happened that I've kind of got a few little thoughts about. I did these slides without consultation with some of the neighbouring councils, although we do talk quite regularly. And so I'll sort of breeze through and sort of adjust what I was going to talk a little bit about. We talked early on, what is the Internet of Things? Ultimately, it's things. You've seen this before many times. What I'd like to highlight with this is it can be pictured really, really simply. The reality is it isn't actually all that simple. And that's kind of part of the problem with this. It's actually a collection of different parts that actually make this all happen. We've talked about the devices, we've talked about the connectivity, we've talked about the aggregation, but then when we take it into database and systems. Now, at each of those layers, there are multiple options of sensors, multiple options of networks, multiple options of aggregators. That creates complexity and does create a lot of challenge for I guess, us in the technology space of things, particularly when a vendor may go and talk to a business area and say, hey, look what we can do. It's really quick, it's really cheap, it's really easy. It could be, but therein lies some other problems. So to talk about a bit of I guess one of the inspirations for us came out of, from, I'll say us, the IT part of Brisbane City Council. We were having some discussions around some business needs. So this is a broad concept around water quality. And we had quite an innovative leader in our city projects office that looked after water quality management. The green dots are manual inspection sites where they go out and take a water sample and send it off to a lab. The orange sites are recreational water health locations that are actually surveyed more frequently. And that's sites where people swim. They are sites where there is recreational activity in water. And so we care about the health for the residents, for the communities. The red dots were actually where we started to say, well, actually, we should be speeding this up. The time from taking a water sample, sending it off to a lab, testing it, getting the results, and finding out that the water isn't actually all that safe to swim takes a week. That's probably not the best outcome for the community. So let's see if we can speed this up. Now, this is where some of the complexities start to come in. Do we have sensors that can test for E. coli bacteria? No, not yet, but that's something to work on. The other general concept here around the use case, which James talked a little bit about before, and Catherine's talked about it, Michael's talked about it as well, and Steph. It's a common sort of topic, but ultimately you'll have the sensor that might be used for an operational need. Turn on a sign at that swimming hole to say it's not safe to swim. That's an operational outcome. Back to what James was talking about, predictive, is you might be using an algorithm to determine whether it's safe or not safe. You might be taking other inputs into that. That's where you want to feed that data into, let's say, a more strategic analysis piece, which is actually where you're saying, can I better predict when that water might be unsafe to swim in? And you enhance the algorithm that then gets uploaded back into that operational solution. So that's the sort of scenario we're sort of trying to work with, trying to explain and enable. Michael talked a lot about the concept of this slide, so I'll keep this one really, really quite short. But ultimately, yes, we have an IoT network, TTN network that we use. It was initially a get this the right way around. It was initially a network trial where we installed 5 gateways to trial the TTN, the LoRaWAN network. We started off with 5 sensors 2 years ago, 5 gateways 2 years ago. And we discovered internally within council, there was another area also doing this. So our field services guys in the operational technology side of things were also exploring gateways. So we merged the gateways and we started to collaborate together. We now have 11 gateways. It's kind of 12 because the Brisbane gateway is actually on 2 frequencies. The others are all on 1 frequency. Just to talk about frequency, that adds or explains a little bit of that complexity. Can you connect to it? Well, are your devices sending through the right frequency? Or did you know about that? So a whole bunch of these complexities. The orange sort of circles is a bit of that line of sight view shed analysis. Should we get coverage? Similarly, last year we put Oyster devices on our garbage trucks and generated an actual coverage map. 56,000 data points captured from the trucks. Now, the reason for that was because we were saying, well, we've trialed the network. We know it kind of works. Yes, it's freeware because, and as Paul was highlighting, it's free for you to use, but there's a lot of councils sponsoring it. There's a lot of work that Mesh do to enable that at the back end. So if you are using it for free, appreciate that there are costs involved. Other people are funding that work. We use it as a trial network now. So it is not a network trial, it's now a trial network. The reason for that is that through TTN, you have somewhat limited functionality. TTI or other commercial grade, private LoRaWAN networks, you'll enhance that functionality. But it's great and it's sufficient for us to test to those use cases. Can we connect? And that's why we wanted actual coverage maps. So we can drill down into any local suburb, any local street that our garbage trucks have traveled down to say, did we get signal? Was that signal strength good or bad? Is it a good spot to trial those sensors? So that's kind of the broad context. And I do think the other part of this, the other element to this story to me is all around collaboration. So there's actually quite a lot of collaboration within council on the different teams who are interested in this low power wide area network capability, the different options. We are a very heterogeneous environment, which I'll come on to in a second. But collaboration with external parties. Talking to the meshed guys when we've come up with little challenges and saying, hey, do you know how to resolve this problem? The Sunshine Coast, Moreton, the neighbouring councils, Gold Coast as well, have been quite progressive with regards to LoRaWAN. The collaboration from our partners. So we don't run a water utility, but the water utilities have some really good locations to install gateways because they're higher up. So we worked with urban utilities and we've installed a couple of our gateways that are actually on urban utility sites. There's a bit of a history, obviously, with Brisbane City Council and urban utilities. But we also collaborated, obviously, with Suez, who are our waste contractor. So there's a lot of collaboration going on as well. We've talked, and others have talked through a range of different use cases. I won't go into all of the details of these. What I will sort of highlight is that there are a vast number of use cases. Now, I titled this slide The Evolution of IoT because to me, IoT has been around for years. Our traffic signal network is in effect an IoT network, a SCADA operational technology type of network. So what we did a couple of years ago is we did a bit of analysis. Where have we got sensors? Is this a build? No, it's missing. Some of the words there aren't too clear for some reason. I'm not sure why they are online. But ultimately what I unpacked was the fact that we have and have had for quite some time, maybe 45 different IoT systems that have been in operation for quite some time. That map is actually just a rough plot of the devices that we know of. And when I say we, again, the IT departments, because a lot of this stuff doesn't happen within IT. This is happening anywhere and everywhere. We mapped where are they? What are the sites where we have sensors? I haven't plotted a whole bunch of other ones, CCTV networks on our buses and fleet management systems, a whole bunch of other devices. The complexity comes in, and I don't know quite why it's not showing, but the complexity comes in with regards to the operating model. A lot of these solutions are siloed, isolated, independent, unconnected. Integration quite often with these things because they haven't been considered and thought through are manually integrated. What that means is you'll go and download a file off a portal that the vendor has provided for this solution, download another file, and you'll manipulate it in a spreadsheet. At that point, you're kind of influencing, well, what's the data quality? Adam Beck made a comment earlier. I'm just going to grab the words because I thought I'd add to this. So he talked about collecting, communicating, and crunching. I'd just like to add a couple of other elements, particularly in that communicate and crunch, is make sure the data is connected and has context. Because without that context, it's much harder to actually bring data together. As I was doing this work, I also uncovered a piece that I talk about a lot, the data science hierarchy of needs. I encourage you to look that up. It highlights, and it goes back to James's comment about maturity to a large degree. At the bottom, we want to collect data. We're actually pretty good at that. Next, you want to store data. Above that, you then want to start to connect and integrate data. And that's where we start to fall apart because it's putting in that context. To get the ultimate outcome of data science, you actually need to be able to merge these data sets, the data sources efficiently and quickly. The operating model is about all the different players involved. So you could have, this is supposed to be model one, where we build the solution ourselves internally. We buy a sensor, we buy a network, we buy that, but we build the solution. So the green is all council elements. Intentionally got a space here. The others might be where you do a full vendor solution. You buy a service, data as a service. So we've got a few of these scenarios. Smart bin sensors. We've got a trial at the moment where we've got a vendor providing smart bin sensors monitoring. They're being used by our malls management guys for optimizing runs. But in other cases, it's a hybrid. We buy a sensor, we contract the telco network, and you've possibly seen the slow for Sam signs or other street signs that are capturing speeds of cars coming backwards and forwards. In Brisbane, the vendor provides the sensor. We may own the sensor, but we provide the SIM card for them, SIM card, yes, to feed the data back. The vendor then supplies a portal. The bottom there is about us trying to bring it all together, and I've left an air gap because that's not always the case. That's the direction we'd like to get to. One other comment, I'm just conscious of time, I'll try to run through. The one thing that we've recently released in Brisbane City Council's new corporate plan is one of the things around the way we work. And it's a new addition, which I think it aligns to James's comment, I think, around their smart city strategy. It's around valuing data as an asset and using technology as an enabler. The priority is enabling what? The why. How do we make things better? And this is kind of where we've kind of played a lot of work around the capability, around education, around saying to the business, what are we trying to achieve? Why are we doing this? What is that objective? What we've found in a lot of the analysis of existing solutions, they go to an objective, they leap straight down to the technology. And you've got the wrong people with the wrong expertise playing with the wrong areas. So the general concept is define your objectives. The IT guys won't often know that. We're probably better at okay, let's now design a solution. But once you've got the objective, don't leap down to the solution. Say, well, if we've got this objective, what are the decisions we need to make to achieve that objective? I need to know X, Y, Z. Okay, well then to make those decisions, what's the data? What's the specification of the data? What locations do you need it from? How frequently do you need it? What level of quality is sufficient? Because that can impact the type of sensor, the value of sensor you buy. Only once you've done all of those sorts of things should you really look at the solution. There is a complexity with this for us at the moment, which goes back to that operating model, is do you want to build, do you want to buy? And let's say that's one we haven't fully answered. I'm not sure we ever will. This is a really heterogeneous environment. Brisbane is a big council, lots of different business areas, the capacity to bring everyone together and you know, say be all on the same page is ideal, but maybe have to be a bit pragmatic about that. But yeah, the ultimate point is, as I said, format, frequency, latency, quality, security. Have we got catalog? Have we got clarity on ownership? Do we have access? And you don't necessarily want to put all of that rigor around everything either, because that can ruin your business case. And we've talked a bit about some of these things. The business case is one of the things that drives it. we built let's call it a trial platform. So we've got the trial network. We can now very quickly support the implementation of sensors and feed data through in that build model, or we can spec things up and push that out to procurement in a buy model fairly quickly and easily. Point being, hot path, you need to make an operational decision, you need an alert, you need to do something with that data now. That's not always the case. We've got some water, soil moisture sensors. They don't actually need to make an operational decision in real time. So they don't really need that hot data. They're using it more in a cold data path where they can say, well, how effective was this infrastructure redesign in feeding water to the roots of a tree to ensure that that tree grew better? Street trees in Brisbane are a very important piece of our environment, of lifestyle. We need to know whether those trees are going to grow well, because I can tell you the street tree growth environment isn't particularly ideal. They struggle. And this gives us the ability to redesign infrastructure and then monitor whether the soil is helping the growth of trees. Very quick, simple pilot we can spin up. It also helps the business in two fronts. One, think through, is that data useful? Do we want to scale this up? Is this working? Now that might just be scaling up the infrastructure, or it may be scaling up the sensors. We're not sure. But it also gives, and this is, I think James also mentioned a little bit around this, is that predictive stuff. Well, and goes back to that strategic analysis. If we've got the data, let's experiment with what are the impacts of different data on a different outcome, or will this help that? So I'll call it that data science experimentation type of work. And just to finish off, I am late. Some of the key things that we've also been, and probably priorities for us at the moment around an enterprise capability is focusing on, I mentioned that procurement piece. So when businesses go and buy things, we've worked very closely with our procurement guys to say, hey, just be aware that if they are buying a sensor, if you're buying a new lighting control system that has technology, consider this, ensure that that data is integratable. May not integrate it because the integration costs, hence the air gap as well. You may not want to, it may not be viable, but be prepared for that and ensure that you can reuse it. And then I'll call it the RACI, the roles and responsibilities. And this is a fundamental piece of the players involved with an operational technology and an information technology. There are people out in the field that need to maintain the devices. They've got a whole bunch of work there. It's not just a sandpit with toys. We've got to be doing this. We've got to be sensible about ratepayers' money. So that's another area that we're really trying to mature, particularly if we're going to build solutions and operate solutions ourselves. Whereas if it's a vendor, it's much easier to cover that out of procurement. So that's all I'll cover off. I'll let everyone head off to morning tea now. Thank you.
Thanks, Derek. Really valuable insights there. I think time and time again in technology, we see that introducing technology is just a small part. The major part is not so much technological change, but cultural change. And I think there's some really valuable insights about how do we, from a cultural perspective, ensure our organizations are well set up to benefit from these solutions. All right, you've been extremely patient. We are going to break for a coffee or a morning tea. We're going to come back in 15 minutes or so, and I can promise you we've got some very, very exciting presentations coming up. You're going to hear about smart beaches. You're going to hear about how to ensure that your town doesn't get flooded. You're going to hear about how we can use data to better understand the economic impacts of COVID in a CBD. Lots of interesting stuff from as we move our way south through New South Wales, down to South Australia and to WA. So go and have a break, and we'll see you in 15 minutes time. Thank you. You got my audio okay? All right, folks, thanks for your patience online. Hope everyone had a good, quick refreshment break. We're zipping straight down the coast to Lake Macquarie, and I'd like to welcome Claire, Chake, and Brian to join us and tell us about the amazing work she's doing down in Lake Macquarie with her team.
Thanks. Hi, everyone. I'm hoping that you can see my screen. I'd like to kick off today by acknowledging the Awabakal people, the traditional owners of the land in which I'm broadcasting from, and pay my respects to elders past, present, and future. They've been innovating for 40,000 years and more, and I think we should continue to be inspired by them and inspired by what they do. Just a little history, Lake Macquarie, we're about 90 minutes to 2 hours from the centre of Sydney. We're over 700 kilometres in area, and we have about 200,000 residents and a gross regional product of about 10 billion. We're part of the larger Hunter region, which is currently transitioning from coal. So like many today, we similarly have the Things network. We've deployed quite an extensive network around our community, in particular to not only support council operations, but to also support our local community in advancing their work in the Internet of Things space and getting experience in that. We recently, earlier in the year, before COVID restrictions, ran a number of in-person workshops with our community, where they got to see the end result from connecting a sensor to the network to seeing the data come through to a dashboard. There are lots of projects I could talk to you about related to the Internet of Things that we do as Lake Macquarie City Council, but I'm going to talk about smart beaches mainly today. So the Smart Beaches project was a project that was funded around under round 2 of the Smart Cities and Suburbs program with the federal government. It was all around making beaches smarter, safer and better using technology. We also were the recipients of the 2020 Australia New Zealand Smart Cities Award for Future of Place. We employed a lot of different technologies as part of the grant project, and we continue to actually expand and use these technologies. And I'm going to take you through a few of them today. But this diagram was a nice sort of infographic that we put together to help us communicate with our community about what we were putting out on the beach and the different things we were looking at. And we found it a really good communication tool because it was visual, but, you know, a little bit fun, and but also helps with these sorts of presentations to give you a little bit of a summary of the different types of technologies we experimented with as part of the project. Now, one of our key pieces of technology, hopefully, there we go, play, was using cameras to count people on the beach. The number of people on the beach is actually a critical data point for understanding what level of risk you have at the beach, and then leading into how many lifeguarding resources should you have at your beach at a certain time. So this is a bit of a time lapse showing a little count. You can see those pink boxes popping up on the screen where the camera, where the machine vision is picking up numbers of people. Now, when we started the process all those years ago of exploring this concept, we went through a number of different technologies to from could we count people using pinging their phones, Wi-Fi, to infrared break beams, things like that. We did conclude that cameras are the best solution. However, although everyone said, yeah, people counting, easy, cameras, we can do that. The problem was all the algorithms have been trained on urban environments. They weren't trained on a beach environment. You can see with the waves in the ocean and the sand, you get people lying down. it's a busy sort of environment for a machine to be looking at, particularly when it's been trained on, you know, very plain concrete environments. You can also see the width of the screen that we're looking at. You know, people can be quite far away, so they have less pixels, which makes it harder to count. So it actually has, it does take time to train these algorithms. But the result is this. You get a dashboard like this, where we can actually see counts. So we get hourly counts based on an average of an image taken every 15 minutes of the beach. And then that forms into also daily counts. Our counting can be done both live, so sending the image to the machine vision processor, which Unleash Live are running for us. And it can also be done at night as a batch report and given to you the next day. We also look collecting data on getting data on nearshore wave height, in other words, swell. We use Manly Hydraulics Lab have developed a model which is based on offshore buoy data. So there's an offshore buoy always recording data. They both have a predictive model as well as a model for real time. They then use the data that's coming off that buoy to tell you what it is going to be at your beach. And you can see here in this graph, this just shows you what the predictions were that the buoy was predicting and what the actuals were based on the model. Now, this is all a model. There's nothing at the actual beach measuring this in reality. However, extensive testing was undertaken to get these results. And we actually have this data, they have this data in this model set up for the whole of the New South Wales coastline. However, I believe that it could be expanded to the rest of the country. We're also looking at continuing to do some testing in this space to revalidate after a number of years since that this model's been running to essentially revalidate that the data of that model that is based on that offshore buoy is coming in, is predicting correctly these beaches. But we have a pretty good idea that it is doing a good job. So here's an example image at two of our beaches, Redhead and Blacksmiths. The offshore buoy is recording a 0.86. It's based on the model, it's saying 0.39 and 0.48 at Redhead and Blacksmiths. And you can see the water's pretty flat. So plus you can see, actually, this is 1st of August. There are quite a lot of people on the beach there, you can see, and even people in the water. So even though it's winter, there are people there, but we have no lifeguards on duty. And this is one of those key drivers around this project of understanding, you know, days when we have things like this, you know, should we be actually having lifeguards there on duty? It's one of the key questions that we're looking to answer through all of our work in this space. And you see again, a big difference predicting big swell and Redhead, smaller and Blacksmith. And you can really see that validation through the imagery. One of our key IoT devices that we found real success in is these GPS trackers from Digital Matter. So this is actually tracking history over a couple of weeks in January of one of these lifeguard rescue boards. And it's really interesting data to explore and look at and to get a better understanding of how much activity is being undertaken and the equivalency of that with the number of rescues that are being undertaken. You can also see this is one of our jet skis. This is for the whole season last year. You know, we don't stick to just our beaches. Our lifeguards are going down the coast to check on other unpatrolled beaches and, you know, if they're getting alerted to calls. But you can see they can cover quite a large distance on the jet ski. So if this is really interesting, important data to use to understand that level of resourcing need that you might need to have. We also track things like signs and flags and when they're going to be up. And this table actually shows me over January in the season, we had one day where we had the shark sign up, and actually that coincides with when the beach was closed. We can see in a number of times where we've had stingers sign go up. And yeah, that beach sign closed up. And this helps us, yeah, get that better understanding of really what is happening and when it is happening, and get data that hopefully one day will lead to our lifeguards not having to do a manual process of writing down when they're doing these activities. Communicating with the public is also a really important aspect. You know, beach safety is not just having our lifeguards there, it's about communicating with the public about what's going on at the beach. We have 2 of these signs available that essentially, you know, we can roll out. They charge overnight. We can also put them into mains power if we need to. And they go through and they tell you, you know, there's a lifeguard on duty, what the local conditions are, who the lifeguards on duty are, weather information, water temperature, swell, tide. And we've also got an ability to add a little, for the lifeguards to add a message on this board as well. All the data that's feeding into the sign, we now have automated. So no one's having to touch, you know, put in the weather data, put in the water temperature, put in the swell, all of that data they don't have to put in. All the lifeguards do in the morning is come in, put who's on duty, and they can add their little message if they want to. We've also been working on an app to make a consistent process for lifeguard data entry across New South Wales. We have a group called the Coastal Safety Group. If you are interested, please let me know. We can hook you up to that group. We have a bit of a community practice of going both nationally and internationally around smart beach technologies and using these technologies to help improve safety and communication. Although smart beaches is a big topic, I thought I'd also squeeze in another separate one about the humble light pole. So a lot of us know poles, they're great assets. We can put our sensors on them, solar, battery power, you can get them up there. You know, these are our, we'll call dumb smart poles. they're the platform for installing things. But they're a great resource and we've used them a lot. However, us, like many councils, have gone down the smart pole journey. We have, this is our first 9 smart poles in Charlestown. And we've done things with them like CCTV, Wi-Fi, putting some like air quality sensors and things like that. And really, you know, what makes these poles smart is about the ability to have electricity to different resources, as well as, you know, these ones have data. But the key thing I want to sort of take away is, you know, you don't have to have data. You don't have to have electricity to every hatch in your pole. You know, there's great value in having a smart enabled pole. You don't have to build everything first, just have it all enabled there for in the future when you want to use it. One of the sort of new things in the space that's going to make some of our, we'll call it dumb poles smarter, is things like having the Zaba receptacle on new street lights that are being installed. This doesn't require you to change the pole, but it does require, you know, when you replace your street light to LED, for example, you can have this Zaga port and you can have lots of different sensors and that can be powered through this. And you can also control the lighting with this. I believe ARC's group might be talking about this later today. We recently run a Zaga hackathon where because this is such a new thing, it's really an emerging space in Europe and places like that. We recently ran a hackathon with businesses that have a presence in New South Wales and a couple of local businesses included in that, to sort of explore what can you do with Zaga. And it's unbelievable in such a low power sort of environment. You know, they really want something about 2.5 watts to about 5 watts is your max. You can really do lots of different things. Things like machine vision counting, people, cars, bicycles, you name it, you can fit it in there. Environmental sensing, Wi-Fi counting, motion detection. You use your motion detection, you turn your lights on and off. You need noise detection. One of the most left of field and interesting projects that came out of this hackathon was Core Electronics created Bird Flow, which is a sensor that uses the songs of birds and some machine learning to detect what birds are in the area at what time. So there's some really cool stuff out there that you can do. And I really encourage you to explore this sort of space. And I really encourage you, you know, in all of these projects, experimenting is key. Don't give up, particularly if something isn't going right. Do more of what's not working, do more of what's working, and do a bit less of what's not working, but keep persevering, because, you know, smart cities projects don't always go to plan, and we've definitely found that. But, you know, you keep at it and you keep growing and you keep changing, you keep learning, and, you know, just be brave, experiment, take the leap of faith. Thank you.
Thank you, Claire. I think it's fair to say that Claire is one of the rocks of the smart city space. The work that she is doing at Lake Macquarie is from the Southern Grampians Regional Council to tell us about some of the exciting. Sorry, got the wrong order. We're doing a circuitous thing. We're going across to the west. We're going to ask John Hawke from the City of Perth to share with us.
Hello, can you hear me? Hi guys.
You're good to go.
All right, great. So I'm just going to get the share going here. All right, welcome from Wajirrgunga country in City of Perth. I've been writing notes furiously, and so many new ideas, so many new projects. It's really impressive how quickly everything accelerates. And I want to echo Claire's words, you have to be brave and experiment. So like many of the other councils, we've done a number of projects. I won't talk about all of them, but we've certainly got into video analytics, irrigation, environmental projects. We were one of the first councils to have an extensive public LoRa network, and yes, we use dual frequency, so 24 gateways, bins, water efficiency, bus stops. But today I want to talk about COVID particularly, because so the response that we've had for, or how we've been managing our COVID response. Can you guys see my screen now? Is that coming up?
Yeah.
Hello, can you? Okay,
yeah.
we're good. Great, excellent. All right, let's go through. So I'm just going to go straight to the operating model, sort of as Derek was talking about. So the fundamental response to our COVID model is we put the sensors in the community. We start our operating model much further up the process into our citizens. So here what we did is we actually placed some of these cheap, but not simplistic IoT sensors directly on, as you see on the screen, on an ice cream shop and a small news agency and a coffee shop. And we have about 2/3 of our devices are actually in businesses. We're talking about, you know, behind the comic book section, on top of the fryer, stuck in a broom cupboard. We literally have plugged them into places that they're never going to use again. Each participating business or stakeholder, also, you know, not-for-profit, so theatres, restaurants, museums, so council facilities and non-council facilities, they all get their own dashboard. So no, I don't give two competing coffee shops each other's dashboards. So this one here, they get to see the train station and sort of our shopping mall, and then their shop. So the whole idea here is, and I want to acknowledge, we've had a very easy time on COVID. My heart absolutely goes out to our colleagues in Melbourne and Sydney who just having a terrible run. Good luck to you. God bless. I hope you go well. But what we've done is that when we've had our issues, the shops and the retailers are able to actually make their own decision. When do they open? When do they close? What's working? So they can look at their own dashboard and decide when to open. So the whole idea is self-service all the way down to the community. So you can see here we've got 21 devices in public parks and spaces, a lot of food and beverage, our tourism industry, you can read it for yourself. So what we're trying to do is to provide an easy way for the users to get there themselves. Yeah, there's always a techie piece. Whilst it's simple at the front end, there's a lot going underneath, and you can see some of the use cases that we've got here, and we've certainly added more since this started. So to James's point before, the processing of getting it out to the front end is complicated, but it works. What I'd like to do, if possible, is flip, because there's nothing better than live. So let's go and have a look. I think they say that thing in the classics, never work with children and dogs. Never work with live data on a video stream. Let's see if we can get this one to work. Let's go with this guy. Sure. Cool. All right. That's not it. I'm going to keep going. So this is an example of one of the dashboards that we get. You can see all the sensors throughout the city, and the citizens or the businesses can find out what are they interested in, what do they want to know about, what do they want to understand. So the questions we've actually solved with this technology is small business owners want to know, when should I adjust my opening hours? Landlords were arguing that they should change the rent. Based owners want to know, how many people going past the front area. We've shared our technology with other councils, so you can see Subiaco Council and 7 or 8 other councils in the area. So they wanted to know what their impact was for COVID. Not-for-profit organisations wanted to know, should they run their event? Should they run it differently, different park, different location? And we were able to give them clear data on that one. Commercial landlords were able to understand, should they redevelop a site? Was it affected by COVID or was it not? Our libraries were able to understand what the patronage was like after COVID. Did it bounce back? Did it not bounce back? We provided this data to WA government, federal government, Department of Treasury, Community Services, Western Australian Police, and other people who are responsible for the COVID response. Our events and security people were able to assess antisocial behaviour. Our park officers were able to determine whether there was an increase or decrease in certain types of activity they were concerned about during lockdown. So you can really see, by decentralizing and pushing out the data, we absolutely maximize the value to the community. So this is some of the data we get out of it, some of the insights. And again, my heart goes out completely to the other councils, but we can really see exactly what happened to our economy. And it's not just the City of Perth for the City of Perth. This is shared. So everybody can see what's going on and they can make their own responses in their own business. We had a lot of our sensors running pre-COVID, so we can make sort of fairly long-term comparisons between our economy now and then. And we can also find out some other interesting facts, like the effects of public holidays and bad weather. We blend this up. It's not just one source. We're running dozens and dozens of technologies, but we blend this up with other data sources to try and get insights on the financials. What is the relationship between expenditure and the nighttime economy? And I'm sure a few councils will use spend map. So our council finds this quite useful. This is a good example of one of our new public parks. We were able to really see when was it popular, what are the strong periods, how many visitors we get. Again, for people in council, this is fairly standard stuff now, but it's absolutely powerful and it really helps with those decisions. All right, let's go ahead and stop that guy there. So for those playing at home, I'm going to put the link in the chat right now, so you can actually go on and get access to live data if you wanted to, and you can see what we're seeing in your own home. I will try and quickly bring up the live dashboard if it works. No, we'll skip that one. The bottom line, guys, is, as Claire said, keep experimenting, keep going. We're a really small team. You're talking to it. So I do the sensors, I do the data, I do the analysis, I do the Power BI, the procurement, the installation, the hand-holding with the shops. You can get a lot of output, a lot of value, even just as a relatively small team. So look, happy to take any questions. Over to you. Hello.
G'day everybody, my name's Russell from Southern Grampian Shire Council. I think I'm up next. Could someone just give me a shout out to see if they can see my screen and can hear me all right?
Yep, can see and hear you, Russell.
Perfect, thank you. Hopefully you can see my presentation as well. So yeah, I'm Russell Bennett, Manager of Business Systems at Southern Grampian Shire Council. I'm going to focus on two specific areas of where we're using LoRaWAN within our region or our shire, looking at emergency management and flood specifically, and then also smart agriculture. For those that don't know where we are, Hamilton is our main town centre, so we're about 3.5 hours drive west of Melbourne towards the South Australian border. Cover quite a large-ish area, over 6,600 square kilometres. Smallish population of about 16,500 people. Council 245, and our biggest industry is agriculture. So LoRaWAN, we've been playing with LoRaWAN for about 5 years now. What's been really great for us is actually seeing the expansion of community gateways, which has been put up, not just council owned. When we went down this path, we always saw us as sort of being the fire starter for this. And we invested with originally 4 gateways back in 2017, I think it was, with the hope that it would continue to grow and the community would get on board. So we now have 12 council funded gateways, but also 5 community funded gateways, which is great. And this little map here shows the indicative coverage that we've got from our LoRaWAN gateways in our shire. And, you know, for such a large area, we're probably covering around 60% of the shire, which is really great. And we're hoping to continue to grow that. So we've been playing with a lot of different use cases, a lot of different sensors over the time. But as I said, I'm going to focus on the 2 highlighted ones. So water levels for our flood sensors, and the sensor in that red circle, the EL2 distance sensors is what we're using. And then I'm also going to do a little bit on smart agriculture as well. So back in 2016, we had quite a significant flood event, which really started our council thinking about how we can better manage events like that. We had a number of properties and businesses with water inundation, and took a bit of time to recover from all that. So from then, yeah, we looked at how we could use IoT sensors data to be able to better understand flood levels, and to be able to make better decisions from a council to move forward. So this is just an example of our spillway at Lake Hamilton, which is right in the heart of Hamilton. It's quite a nice little trickle over the spillway at the moment. That's about, well, it was 10 millimeters over the spillway level, which caused that trickle, which is quite a nice, like a little waterfall, quite pleasant. And that was just taken a couple of weeks ago. But why we're doing this is to manage events like this. So this was in October last year, October 9, where we had a fairly, again, significant flood event, spillway massively overflowing, closing that road there, but also the impacts downstream is why we're going down this to make better decisions. So this, on October 9, we were over 500 millimeters over the spillway. Our levels were in that lake. And we knew this because of the data we've been capturing for quite a number of years now. So that, on that map there, I've got a little red circled area. This area here, when that spillway gets to like it was in that last image, that's the area of town that is subject to water inundation in Hamilton. And so from a council perspective, there's triggers that or actions that we do when events like this happen. We have a manual water levy that our infrastructure team deploys there to divert water away from that location to protect those properties. And so we can use this data now to help us make better decisions, help manage that event better based on water levels when we trigger actions, when we notify our community, and so on. So on the right, there's a little picture of the actual water sensor in Lake Hamilton, installed onto the guidepost there with the lovely bird as a prop. So we use the gauge sensors to calibrate those sensors when we put them in, and it is pretty damn accurate what we get from these sensors, which again are fairly inexpensive. You're looking at around the $500 mark per sensor. So this graph here is showing the water level for Lake Hamilton that we've got since 2019, and it's peaked there. I've highlighted that October event in 2020 where we really saw a massive peak going over 500 mil there. But having this data and having previous events so that we can understand it helped us essentially save properties from being damaged in this event in October 2020. This is probably, with all the trials that we've done with IoT and sensors and LoRaWAN, this is probably the one I suppose that council hangs its hat on, or I hang our hat on in regards to one of our better use cases or solutions, because it's driving business decisions based on that data, which is super awesome. The other business decision we make out of this, not only around emergencies, but we have, I think it's a local law around managing water levels within the lake as well. So we're using there's a valve that can be open to let water out of that lake, controlled water out. So we, again, use this data to make sure that the lake is within the tolerance levels set within that local law. Instead of having to send someone out to visually inspect, they can look at this data, they can make decisions, they can be more efficient, which is what this is all about. So we have more than one water sensors. So this is, again, this October 2020 flood data. So that Lake Hamilton is sensor 4 there on that map. So we have another 3 upstream. And what's really been interesting to again, capture data over time to really understand how the catchment works. So in the event on that October 2020 event, we know, and we sort of knew this before from other events we went through, but this was the largest scale one we've had since these sensors have been installed, that from sensor 1 upstream to sensor 4, once the water peaked at sensor 1, we had 17 hours before that peak actually hit the spillway in Hamilton. So again, having this data has helped us better understand, where our trigger points. If we know the water's still going up upstream, we definitely know we're still gonna, we haven't seen the worst of it at Hamilton. At the lake there at the spillway. So we, again, making better decisions, understanding how that catchment works so that we can provide a better service, again, whether that's when we deploy our levy, when we communicate or alert our community, whatever it may be. So yeah, really valuable and helping us in that event. It saved us. It saved properties from getting inundated, which was great. And the other thing that we're doing, we're releasing this data publicly. So we have what we call a smart community open data portal, which is powered by a product called Open Data Soft. And we're sharing this data publicly, and it's being used by other agencies, which is great. So SES tap into this data to help them with their efforts in regards to managing emergencies. And also the local catchment management authority are very interested in this data. They have 1 or 2 similar sensors in different parts of the Shire. So instead of them forking out more money and replicating what we've got and vice versa, we can share data across those agencies, which is really good. Moving on to smart agriculture. So as I mentioned right up the top, agriculture is our largest employer, so of our shire, within our shire. So for us, if our agricultural community is thriving, our shire is going to thrive, our region's thriving. So when we invested in Lorawan back in the day, it was always around the community side of things, economic development side of things. How can we help our agriculture community? How can we attract businesses and all that sort of stuff? So we've been doing a lot of work with our agricultural community to try and push out the knowledge and get the understanding out there about the opportunities that not only Lorawan, but IoT, smart agriculture as a whole can bring them. And as part of those efforts, Council started what we call the Digital Innovation and Smart Agriculture Festival, or smaller name DISA. Back in 2019 was our first DISA event. We really didn't know what we were doing back there. We sort of had an idea, and in the end had really good backing from council and some key sponsors, and we gave it a crack. And it was a really good event, a really great experience, and it really brought together, we had local farmers, we had industry partners, we had vendors, and we had other local councils attend this, and all learning about the opportunities for smart agriculture, which is fantastic. As part of that 2019 event, we partnered with 4 farmers in our shire and set them up with smart ag solutions, all different farmed with different solutions. So for instance, we had one set up as Lorawan, and council actually provided that tech, set that up and provided them with dashboards to see tank sensor levels and electric fence monitoring, soil moisture, weather, all that sort of stuff. We had another farm that was leveraging Telstra technology, another farm leveraging satellite technology by a company called Fleet Space. And the 4th farm was a company called Wild Eye, who sponsored us there, which is a company out of New Zealand that uses cellular technology. They've been around for a long time, so have a very robust solution. But it was great to take the community, the farmers, through those farms to understand what's going on. And so 2019 was really good. We were going to do one in 2020, but everyone knows 2020 was a write-off. We were very fortunate to have our second conference in 2021. It finished 2 days before lockdown in Victoria, so we were very fortunate to get that in. But it was amazing to see the transformation in 2 years in this space. Like when we did it in 2019, there wasn't much off the shelf products that farmers could just go and trial and get into the market. Coming in 2 years later, there's a plethora of vendors out there now that are offering solutions and offering opportunities for farmers to better manage their farms, which is really good. I'm just going to, I was going to play this video, but I don't reckon I have turned on the sound to come on. Let's see if we can make that work. Just shout out if you don't hear some sound with this.
I have brought with me Telstra's Smart Farm products, which is currently in its pilot phase, and we're testing this out with a few of our customers to see if we got it right. It's really just a small monitoring solution that allows customers to remotely monitor aspects of their property. They can actually leverage off Telstra's existing IoT network, which gives connectivity in places where your mobile phone just doesn't work.
Across everything in farming, whether you're spraying or just understanding how much rain you've got to then make decisions from that, it's a big help.
We cover such a great area on our farms that, you know, it's silly not to use some of this stuff that can help us in our day-to-day life. We've got some tank sensors, some water flow meters, battery sensors, and looking to get some gate sensors and different things to just try and cut down on a bit of the man hours that it takes to deal with the day-to-day jobs on the farm, and B, probably a little bit of added security.
It's very easy to install. It's probably their hub, which I think is the big advantage. It's basically a one-stop shop where you can have your tank levels, your weather, rainfall recorded, wind, humidity, temperature, and also hopefully cameras into the future, checking troughs and security sites.
I think it's worth looking at. I think especially on big farms or farms that are spread out, you know, the time-saving efficiencies, they're something that's really going to be handy. Having the monitors there to tell you when the water is low or when there's an issue will be a lot easier than driving half an hour to go and physically look. So I think those sort of things will definitely be a time saver. The sensors aren't very expensive, they don't use a lot of power and they don't require subscriptions. So I think for those sort of factors, it make a very handy little network to have.
Cool. Hopefully that worked. But yeah, that was our 4 farmers talking about the experience on the actual day that we took those farm tours. A couple of busloads of people around, which was really good. But the other thing I touched on before around the economic development side of things for Lorawan, which is one of the key areas we went into. Like, innovation is an area everyone wants to invest in and nurture within their areas. And, you know, when I started back in council in 2015, there wasn't a hell of a lot going on, but, you know, investing in this Lorawan has seen Farmo created. Farmo is a local farmer, Nick Seymour, who's an engineer by trade, but has a farm in our region. He saw what council was doing with Lorawan and was really sparked and interested in him going, you know, I want to be able to better manage my farm myself. And so being an engineer by trade, he started really understanding Lorawan and created his own business. He is now building, supplying, supporting smart ag solutions based off the Lorawan technology to local farmers, which is great. So it's a local startup. At the moment, it's only one, but for us, that's still a big step from where we were years ago. We're hoping that stuff like this will keep on growing as we continue nurturing Lorawan and opportunities with sensor technology. So Nick's a really great story for us with Farmo. I think he's got around 5 or 6 customers in our shire and a few outside of our shire. He's contributing to the Lorawan expansion by putting more gateways on local farms within our shire. And he's offering, you know, a dozen different solutions from tank sensors, gate sensors, electric fence monitoring. The list goes on and on. So yeah, it's a really good success story for us. And that's me done. Thank you.
Well, hello everyone. My name is Georgie Johnson and I'm Smart Cities Project Officer for the City of Marion in South Australia. I hope my audio and video and presentation will continue working. I'm currently in lockdown in Auckland, New Zealand after a family holiday, and we are experiencing a storm, which hopefully won't interrupt today. So I would like to acknowledge though that the City of Marion sits on the traditional lands of the Kaurna people, and we recognise the Kaurna people as the traditional custodians of that land. And so, yeah, would just like to acknowledge that. little bit of context for those that don't visit South Australia or may not know where the City of Marion is. We sit about 10 minutes south. Our boundary starts of the CBD in Adelaide, and we're a small council. When I heard Claire's stats, I looked at what our GRP is and resident population. So I think we've got some progress to make there, Claire. But yeah, we're one of the 5 largest councils in South Australia. There's about 18 metro councils and 68 councils across the whole of the state. So we're one of many voices, but are pleased to be here to represent South Australia and the City of Marion today. So in our smart city context, I am our smart cities team as well. I'm responsible. I wrote our smart community strategic plan, which is called SmartCom. And for us, that underpins all the work we do. I actually wrote this plan while I was deploying our Smart Cities and Suburbs Round 2 funded project, which I'm going to speak about today. But the plan really underpins for us 3 goals, which is smart places, smart community, and smart organisation. And so that is a key driver for us, and the foundational principles sit underneath it, and that is right there at the bottom of your screen. But ultimately for us, it's about creating a sustainable community for all. And we mean all of our community, those that visit, those that are residents, and pay rates towards the work that we do. So there's a couple of things I'd like to share with you today about. So it's our Oakland Smart Precinct, Dwyer Road Reserve, which is a local reserve that we did a precinct project centred around. And the Connected Cities Network, which is a collaboration across multiple councils in South Australia. So my presentation is possibly slightly less technical than some of the others that have been presented, but you've probably at this point had enough information, and so just enjoy my pretty pictures. So this is the reserve view that you can see. We've installed a number of pieces of technology throughout the precinct, and this connects a major train station upgrade that the state and federal government did through to our regional centre, which hosts one of 2 Westfields in Adelaide, and our local cultural centre and a swim centre as well. And so we wanted to create that connectivity through the precinct for our community to be able to utilise public transport and be able to create a space that they could dwell in while they waited for that transport or waited for their movie to commence, that they could take their children to locally or regionally to. And so we've used technology in this reserve. It's our first expression of technology. It's the first smart precinct in South Australia. And so we heavily relied on our partners to make progress in this development. And so early on, we engaged Meshed. So we were very fortunate to partner with Meshed as an organisation, and I really do mean that partnership phrase when I say that. Catherine, Paul and Andrew and the team worked really closely with me as I navigated through what our context of a precinct would look like, what problems we were trying to solve, ensuring that our community was at the centre of what we were doing, and then coming up with solutions that would help us to achieve the community connection and innovation outcomes that we wanted to have in this precinct. So first off, we deployed a LoRaWAN gateway locally. We tried to deploy it on a high slide at our swim centre just a little bit further north, but found trouble with power at our installation. So in the end, we brought it to site and installed it on infrastructure within the reserve and precinct. So the image at the bottom of the screen is how the gateway was installed on a piece of solar infrastructure. We determined to power it though, rather than run it off solar after the power issues we'd had at the other location. But this is an image from the TTN mapper that shows the coverage of that gateway. We have a couple of other gateways deployed across the city, and so in South Australia we have really great coverage of LoRaWAN as a network. And for us, it's a really sustainable way that we can introduce technology for our community, giving the community access to the community side of the network, but we also run the things industry for our lighting solution, but I'll talk about that in a second. So we deployed a number of different technologies across the precinct. As I mentioned, we were successful in the Smart Cities and Suburbs Round 2 funding, and so we were really thankful to have other councils that had gone before us, like Perth, and we learned a lot from what they'd deployed in their Round 1 funding and their project. But we really wanted to bring it into the context of Marion and into the context of the community of the reserve that we were upgrading. And so for us, some of the sensors are deployed on 4G technology and some of them are deployed on LoRaWAN. So I'm going to focus today on the LoRaWAN solutions, given that Meshed is the partner of this conference. And so for us, we deployed an Encounter, which is a people monitoring device. And that's giving us data around numbers of people that are in the space and the dwell time. Some of my other colleagues have presented the data that they're seeing from their people counting devices. So I don't really feel like I need to go into any depth around that, but I'm happy to take questions if people have any questions around any of these solutions. We deployed our first recycling bin in public realm. We have a great waste program for our residents. And so I really wanted to introduce a recycling bin in our public realm. But in order to understand how that was going to work in our community, we decided to put a fill level sensor on that through Clean Cities Network, which was in partnership through the catalogue of Meshed. And so we can tell the fill level on that. We're currently emptying it only on the residential fortnightly pickup system. So we want to understand if that bin is filling up faster than that and enable us to respond to that operational need if it occurs. We also deployed smart barbecues. So we have a dual plate here from Christie's Barbecue on the LoRaWAN network. We partnered with the ARCS group and Meshed, and like I mentioned, deployed the Things industry for our smart lighting solution. Given that we had federal funding, I could have deployed smart lighting poles, but we decided.
This is Brendan.
We decided that we really wanted to have a solution that was scalable without needing that federal funding, and so we decided to go with the ARCS group and a NEMA cell on top of a standard LED light fitting. And so you also can see on that pole we've got a weather station which connects to our proprietary irrigation system that we've had for a number of years, and we also have a smart parking sensor. So like Claire pointed out, the pole can be magnificent in taking care of technology and installing your sensors on. Another LoRaWAN use case that we're doing at this precinct is we're actually trialling 2 different types of turf in our space. So we wanted to be able to monitor the watering that's occurring in that space and see if the turf is responding the way that the product declares it would. So the Tiff Tough brand believes that it's 30% less water, 38% less water than other varieties. And for us, that would have a significant operational saving and would be really beneficial for us to scale across our reserves. We have close to 300 open spaces, and so as we needed to replace turf, that this would be potentially a really great opportunity for us. And so we've installed a couple of sensors on some flow meters. This is where I would say that Brisbane City Council talked about the complexity of sensors. Derek did. For us, our installers haven't installed these digital nodes correctly. And so there's a lack of maturity in the South Australian market around installation. And for us as an organisation growing in our maturity as myself deploying it and my maturity of it, this use case hasn't quite worked with the technology, but it's in no way the technology's fault. And so we're navigating through those trials and challenges as we continue to look at the data that is and how we'd use that. So another couple of use cases that we deployed through Meshed, we deployed this product called a Guppy, and it's a vibration sensor. And so we deployed it in 3 different places across the reserve: a basketball, backboard, a seat, and the Modi multiple play piece of equipment that we deploy in a lot of our reserves. We found that the basketball hoop was giving us the most important data out of those 3 use cases that we could replicate. So we've actually relocated those other 2 sensors across basketball across our city already. And so we're really enjoying seeing the data of how the community are engaging with that specific piece of equipment that we deploy often in our reserves, and understanding the value of that to that local community and the times that it's being used. We have a couple of other use cases that we deployed, which actually were through SAGE, still on the LoRaWAN network. So we have a radar sensor that's detecting swings utilization. And also we created these custom solar panel pieces of equipment, and understanding the energy and the solar power utilization and the draw that's coming off those solar panels, so you can charge your device while you're sitting in the reserve. And so we wanted to understand how the pieces of equipment are being utilized by the community. Lastly, I just want to talk to you quickly about Connected Cities. So Connected Cities was actually a round 1 Smart Cities and Suburbs project, which was led out of the City of Prospect, which is a South Australian council, in partnership with all of the councils that are listed on this slide and meshed. And so they went about deploying a LoRaWAN network across, as you can see from the map that's on screen, and had a number of use cases specifically for each different council. So we've gone about looking at those use cases at that specific council level, and how they've been able to use that data and what they've been able to do with that data. It was a really great model for us to acknowledge that we all do very similar things across our council boundaries. And as I mentioned, with 18 metro councils, we cross over each other's boundaries quite regularly, and the community certainly do as well. And so we looked at scaling this, the idea of collaboration around Connected Cities. And so I think we're up to 16 of the 18 metro councils are part of Connected Cities Stage 2, we call it. And it's a collaboration. And so we've chosen one use case. And so we went about leveraging a local government association grant to deploy this use case. And so we've installed the encounter pedestrian monitors along shared use paths in these councils of the 16, but all of the 16 councils will have access to the data. So this is just a screenshot of the mesh dashboard that we have around the encounters. We're still in the process of installing some of those counters, but we really wanted to gradually work together to look at how the community are transversing along shared use paths that go through our council boundaries, and then analyze that data and the impact of things like other people have talked about, weather events, local events, and the impact of seasons and the utilisation of the infrastructure that we put a lot of money into. And that is a really key objective for our state government, as well as walking and cycling. So we wanted to look at those that as a use case together, and we're already talking about other use cases that we could scale this kind of collaboration to, and gain awareness of how the community are using it by collecting data. So thank you for listening. If you'd like to connect with me on LinkedIn, please feel free to scan the QR code or go old school and type it. It's been great to be part of today's sessions, and I really appreciate the opportunity to share with you what we're doing in South Australia.
Thanks to Georgie. That brings to an end the local government use case section of the event. We're now going to flip across to talk to some of the technology solutions that are being developed by very innovative companies. We're going to start with Andrew Maggio, who's the head of technology and co-founder of Meshed. Andrew is going to talk to us about some of the exciting ways that these networks that we're establishing can potentially be commercialized and have even greater utilization for industry and business out in the community. Welcome, Andrew.
Hi, ladies and gentlemen. Thanks for joining. I'm coming to you from sunny Sydney, where I'm enjoying lockdown life at the moment. Hopefully not too much further to go. But I'm going to talk to you today just about our network technology and something that we're planning for the future. And I'm just going to go off video as I run the presentation. Firstly, a bit about Meshed for those who don't know us. Meshed is an Australian private company. We started in 2015 to provide services in the Internet of Things. We provide LoRaWAN infrastructure, expertise and managed services, mainly to local government, but also state and federal and enterprise clients as well. We have end-to-end solutions comprising sensors, network and data platforms, but also a subset of those things. We've got customers all over Australia and New Zealand, and we've helped more than 60 councils to establish free-to-access community LoRaWAN networks, and that's based on the Things network. Over 100 councils have adopted LoRaWAN as their IoT network over the last 4 years, and over 70 of those using Meshed's methodology. We have a number of enterprise customers on board as well. One of the best things about LoRaWAN is that it has so many use cases. There are now hundreds of types of LoRaWAN sensors available. These are just some of the common examples, but there are far more than this. Here are a couple of real-life examples. Many Mesh clients are using smart parking discs like this one to find out about parking patterns and utilisation in their commercial areas. They can display data in a dashboard, such as the one shown here, but our clients also have access to that data for further analysis. The data can also be made publicly available through third-party platforms. People counting is one of the most popular applications for councils with LoRaWAN, and this meshed people counter, the N counter, can be placed almost anywhere to give councils real-time data on patronage, attendance, and pedestrian patterns. So to do IoT, you need an IoT network, and many of you are already using the Things network. Your gateway investments have created a solid network presence in your regions and indeed a strong presence across the bulk of the Australian population. This gateway, for instance, is in Wollongong on top of Mount Kira. All the buildings you see there have a line of sight to the gateway and potentially can use it to send IoT data. It's just one of several gateways in the region, by the way. There are about 1,200 gateways registered in TTN at the moment, and several hundred of those are council-owned gateways. When Mesh started this LoRaWAN journey back in 2015, there were just 2 gateways in Australia, one in Sydney, one in Perth. But what if your council could be compensated for the investment it's made in LoRaWAN gateways by forwarding other non-TTN user data, such as data from industrial, commercial and enterprise users? Organisations such as these often require a service level agreement for their network. Some need the ability to send more data or need more control over the network. These organisations typically use a private LoRaWAN network to achieve this, but in many cases would welcome the ability to use councils' existing gateways where possible. Additionally, some companies don't have the means or the locations to deploy gateways themselves, so it's highly beneficial for them to use council gateways in a private network scenario. For instance, what if a water utility wanted to deploy a LoRaWAN solution across your LGA? What if a smart lighting solution provider wanted to do the same? Or for that matter, any number of smaller solution providers who have a LoRaWAN-based product or service to offer. What if the cost of councils' gateway deployments could be reduced? What would this mean for expansion of the network? What if this all led to lower capital outlay, lower maintenance costs, more efficient network usage, and more incentive for councils and local industry to work together, use the available assets more efficiently and potentially grow the network together? This is why we created Meshed Exchange. So what is Meshed Exchange? In summary, it's a collaborative LoRaWAN packet exchange. It allows gateway owners to receive credits for forwarding data packets to the applications of private network users, and it allows private network users to pay for those packets without having to install gateway infrastructure. It's based on 3 pieces of technology. The ThingStack Enterprise Edition, which provides the LoRaWAN network server layer. MeshedX, a high availability multi-tenant hosted network platform, which also hosts the exchange. And Packet Broker, which provides the routing of packets between organizations. Let's take a look at how it works. In this example, a LoRaWAN device deployed by a private network user sends a data packet through a cancel gateway. Those packets are forwarded to MeshedX. Then via Packet Broker, the data is forwarded to the private network user's application. Mesh Exchange then creates a charge record for the user, retains a small amount for the operation of the exchange, and creates a credit record for the gateway owner. Monthly invoices and credits are generated and then applied to the respective organisation's accounts. Public network connectivity is unaffected. Any data forwarded to the Things public network continues to occur at no cost. A positive side effect of Meshed Exchange is that through the use of Packet Broker, gateways become decoupled from their home network. Now devices can use the gateways closest to them. This results in devices using lower power settings and spending less time on air, which results in better battery life for the devices and increased network capacity at the gateway. In summary, signing up to Meshed Exchange as a gateway owner is opt-in. It helps to optimize LoRaWAN spectrum, helps to avoid duplication of gateway hardware, and encourages expansion of the network. Provides an opportunity for councils to subsidise their investment in LoRaWAN, and it reduces deployment costs for private network users. It is essentially a marketplace, and as such, it needs both sides. It needs gateway owners and it needs private network customers. It may be a slow burn initially, but we're confident that Meshed Exchange is a good solution for our growing LoRaWAN industry. If you have local businesses in your area who may benefit from a private LoRaWAN network and Meshed Exchange, ask them to contact us about getting on board. If you're interested in registering your gateways, get in touch with your Mesh representative. I'd like to spend a few minutes talking about the ThingStack version 3 as well. If you're a TTN version 2 user, then no doubt you've heard about the need to migrate to version 3 before the end of the year. This comes in 3 parts: creating your V3 integrations, migrating your devices, and migrating your gateways. If you're a Mesh gateway customer, either we've already migrated or we'll soon migrate your gateways. If Mesh is maintaining your applications, then it's likely that they've been done as well. If you're in control of your own V2 applications, then now's the time to get your devices migrated. V2 will be shut down in December and all unmigrated devices will stop working at that time. There's some very good information and documentation on the Things Network website about migration. In summary, first consider your integrations, then devices, then gateways. Once you migrate, here are some of the things you can expect. These are some of my favorite features, not necessarily the ones on the brochure. Stability. So Mesh currently hosts and manages the V2 cluster in Australia on behalf of the Things industries. We also host a large V3 private cluster, MeshedX, as I mentioned earlier. V3 has been a much more stable platform today. Configuration. There are many configuration options available for devices and gateways, which were just not possible in V2. Class C support. This allows the use of not just sensors, but also actuators. For instance, the ability to turn on an electric motor using a LoRaWAN-based switch. API first. The ThingStack has been written to conform to a set of APIs. If something can be done in the web console, it can also be done on the command line and also via API. Device names. We finally have friendly device name fields, which you can use at any time and change at any time, which makes presentation of device data much more usable. Attributes. You can assign arbitrary attributes to gateways and devices, which you can read later, say in integration code. For instance, you can assign a version attribute to a set of devices, then depending on the version number, decode the device payload accordingly. Thank you for watching, and you can find us at mesh.com.au.
Very innovative approach there in terms of how do you sweat the investment that you've already made in your network infrastructure. I think that's going to be a very interesting solution. So congrats to the Mesh team on that. These chairs in this facility are designed for a maximum of beyond that point, you require acupuncture or something of that ilk. So that means we've only got 20 minutes left of usable time. And I'd like to invite Catherine from Meshed up to the stage, and she's going to moderate a panel of 3 super innovative companies that are working on sensors and solutions that allow many of the use cases that you've seen today.
Okay, so this is interesting. So we have the panel members. So I'd like to introduce, I'm not sure why John is there, but that's okay. He's most welcome. So what we're going to do is this is a fast and furious tech panel. Today, you've seen so many different ways that IoT can be deployed, but these things don't happen just for sheer, luck. There's a lot of stuff that goes behind the scenes. So we're going to get a little bit unpacked about what happens behind the scenes. And we're going to look at the through to the right choice of sensors, all of the great things that Derek was saying about trying to pull together all these moving parts, moving then into the applications and the use cases, and then finally closing up with some really great examples of how data is being used and shared. So I'm going to introduce Sam Fisher from ICT International. We have represented Tasmania today, Chris, because Sam is calling in from Hobart. So
thanks.
oh, no. Oops. There we go. Thank you, Sam.
Thanks, Catherine. Hi, everyone. I'm Sam Fisher from ICT International. We're a business that's been deploying and developing environmental monitoring solutions for over 40 years now. We're headquartered in Armidale, New South Wales, but as Catherine said, I'm out of Hobart. And we really specialise in plant, soil and environmental science. And I think Catherine really nailed it in the introduction this morning when she was talking about the evolution of telemetry, because coming from a hydrometric field, which is my background, that's what we've really seen. We've been collecting field data for over 50 years as an industry, but the rapid shift over the last decade and the miniaturization and the move to an open standard has really progressed the industry and changed the way we're doing things. But what we see is a lot of the problems are fundamentally the same when you're collecting field data, in that the constraints and the risks remain unchanged. So where you've moved from a station that's a shed on a river to a shed in a monitoring solution in a box, a lot of the problems you've historically seen in deploying these monitoring systems remain unchanged. And a couple of the constraints are obviously deploying your data or your sensing in a manner that's going to yield you a representative data set, provide some capacity to ongoing maintenance, which I think gets overlooked time and time again, and that is sensor cleaning and calibration requirements. So when you're planning and you're looking at a sensor, that's one thing we definitely recommend you look at. And then if you do have to maintain it, how that fits in with your OH&S, and whether you're climbing up poles to clean a sensor or fix some bearings on an anemometer, whether you can fulfill that in your OH&S program. And then your risks, and in hydrometrics, you're deploying electronics into an environment that floods and that is often prone to vandalism in the urban environment. So we sort of look at those constraints and risks when we're planning to deploy a system, and come up with try and come up with a system that's going to tick all those boxes. And this is a quick example of an installation we did for Redland City Council earlier this year to do some in-stream water quality monitoring. And as you can see in these photos, all electronics is accessible at ground level. So the person going out to maintain the system can drop a pole to physically wipe down a solar panel, check your electronics inside your box. The sensors, which aren't cheap, housed in a steel cased lockable enclosure, and they can be sleeved and pulled out from bank level to do your cleaning, which with any water quality sensor you're going to have to clean it, and to do a calibration, which is for these particular sample of sensors, generally 6 to 12 months. So that's something that you need to consider at the outset, and plan your installation and your monitoring program around those constraints and risks. Thank you.
Closely with us on a number of environmental projects, and the complexity is definitely shown in that slide. So now I would love to introduce Phil Locke. Phil has been a great partner for Mesh from the very early days, from the ARCS group.
Oh, the bandwidth may be a little bit limited. Can everyone hear me okay?
So, yep, just get to this.
Yep. So Phil Locke is my name. I am a co-founder and director of the ARCS group. We have been in the rail industry historically for around 35 years, and in the last 7 years been engaged in the smart city technology area. Our background in rail has been SCADA, so we've taken those engineering principles and brought them into the smart city and IoT world. I want to talk very quickly about the Moreton Bay rail link pathway that James Pete mentioned earlier. We were given a task to create an adaptive lighting solution for that pathway. We had an existing LoRaWAN light controller, however, it didn't fit the purpose, so we developed and extended our current range to include a LoRa-based NEMA DALI 2 controller. The differentiator for this controller is it has a DALI 2 application controller on board. We believe it's the only one in Australia, if not the Southern Hemisphere. It allows a NEMA fitting to be on top of the light, and then a Zaga presence detector on the bottom of the light, which creates a tactical light control locally. And that data and information is then brought up to our middleware platform called MeshNet Vision, which we've created from scratch to assist us in our engineering and data analysis, but also normalize the data up to the higher enterprise system. So it's a fully functional user interface. I've got a little bit of a demonstration there of how these lights work. We've employed one of our young engineers, and you'll see him walk underneath these lights in our office in Western Australia, and they come on tactically. These lights you're seeing there are actually about to be deployed with Michael and his team related to the turtles in the Sunshine Coast. But you'll see the light come on automatically, and James, I think, demonstrated a screen where you can control the amount of time that light is on and when it goes off, and then the normal level of light control. So we developed these from scratch. We build and design them in our Perth engineering office, and we believe we're one of the very few Australian-owned and designed IoT companies in this space. We're known as problem solvers, and we'd love to have a problem to solve. Any questions, go to our website or give me an email or a call. I think that's a quick way to deal with it. Thank you, people.
Thanks, Phil. That was great. And the technology worked, which is even better.
Yeah.
So you've seen the planning and design, the choice of the sensor, the whole, things to think about for installation. Yeah. and of course for shared local technology being deployed in the lighting area. Now I'd like to introduce Paul Painter. Paul is from Pecklet Technology, and Paul and Mesh kind of follow each other, but he'll explain a little bit more about data. So I'll just carefully put the slide on. There's a little bit of delay. There we go.
Cool. Thanks, Catherine. Hi, everyone. As mentioned, my name is Paul Painter from Pecklet Technology. My company specialises in data analysis and visualisation. We use a multi-purpose SaaS platform for smart cities, IoT, and open data. It's called Open Data Soft. And on the screen, you'll see 3 examples using the Open Data Soft platform. On the left is the City of Greater Geelong have a Weather Together program, which is working with their community to improve the accuracy of weather data. Residents can volunteer to host the council's LoRaWAN weather sensors at their home or workplace to record temperature and humidity in different parts of the city where climate can vary significantly. And that data can be visualised on the public-facing dashboard. In the middle, Randwick City Council is using multiple data sources to be visualised on digital beach displays to help improve the beachgoers' experience and safety in Coogee Beach in New South Wales. And on the bottom right, just recently, Open Data Soft has been integrated with the New South Wales and Victorian Digital Twin, and I think Queensland shortly as well. So, and that's real-time IoT data can be sent to those digital twins, which I can show a demo later if anyone's interested. Now, I'll quickly share my screen. And Catherine, yell out if you can see that screen.
Yes.
Yep, you can see the Weather Together screen. Fantastic. So this is the live Weather Together dashboard that anyone can go to right now, where the residents are going to be installing in sensor in the backyard. They're going to provide an image of the location of where their sensors are, where they can also view on a map. There's currently 3 sensors that are installed, but this is going to grow to about 50 sensors. They can come in and see the local weather data or the historical weather information with some sort of basic filtering capabilities. Then they can access it or download the data, but then you can go into view the data on the Open Data portal, Open Data Soft portal, where you can do really more analysis on that data. You can obviously see the table. You can come in and visualize and create your own maps. You can come in and really analyze the data like Power BI. It's, you know, Power BI for everyone internally and externally. You can actually share this via URL. You can embed into websites. You can edit in advanced mode. You can come in and export the data in multiple formats. You can, you know, do self-service API to send data off into different applications, or you can share via social media. Now, with the Randwick beach display, you can see here multiple data sources coming from Environment New South Wales for safety, information and pollution, lifeguard reports, and multiple sensors from, you know, the meshed LoRaWAN, whether it's lockers, barbecue, waste, parking, ride share, etc. And for more use cases, yeah, please feel free. We have an open data portal called data.pecklet.com.au where we upload all our clients' use cases in open data portals. Thank you.
Thank you, Paul. So a couple. I know Geelong and some others. So that's just a really quick wrap up. We'll now move to, thank you, speakers. That was great. And we'll now go to Chris.
I'd just like to say a few thank yous. Firstly, thank you very much to our audience, the folks that came today, to our in-person audience, the folks on our online audience. I see we've still got 70 or so. I'd like to pay a special complex. There was a hot stopping moment, as you saw earlier, when Zoom, just for some random reason, gave up on us. But thank you to the team for your amazing efforts pulling that together. I'd like to thank our various presenters for taking the time to prepare and present today, and most importantly, the generosity to share knowledge and use cases and case studies. While I said earlier, we've faced kind of massive challenges from a local government perspective, we also live at this time where we have unbelievable opportunities to collaborate. And I think the nature of this technology is that it really lends itself to collaboration. And I think that's why there is such a kind-spirited meshed Catherine and Paul for helping co-organize and introducing us to all of your amazing friends that you've made over the years. And we've certainly very much enjoyed engaging with those folks. Hub, and of course Noosa Council. So the last step, I must not bugger this up, the last step is that having heard all these engaging presentations, but not having had the chance to do any Q&A, we've set up a Q&A session for those of you that are online. If you would like to connect with any or most of the speakers that for those of you that would like a little bit more information or to connect with any of those folks, that's the thing to do. And with that, I'll say thanks to everybody again, and we'll wrap it up. Thank you.